Okay. Yeah. Very good morning. Welcome back to day 4 of 1 week FTB on secure cloud, artificial intelligence, and distributed system. So today first session is going to handled by Dr. John Paul Martin. He is currently serving as an assistant professor in IIIT Kottayam. He holds a PhD in CSE from NIT Surathkal. He is a recipient of the prestigious Vishweshwaraya PhD Fellowship awarded by the Ministry of Electronics and Information Technology, MeitY, Government of India. He also holds a MTech in Information System from Mahatma Gandhi University and a BTech in Computer Science Engineering from University of Calicut. He was recruited as a knowledge associate at SCADS R&D through a super dream placement offer from NIT Surathkal. He published 5+ SCI Scopus journals, 11+ Scopus indexed conference papers, and 3 Scopus indexed book chapters. He is a reviewer of peer-reviewed reputed journals and Scopus indexed IEEE Springer conferences. His research areas are distributed computing, edge fog computing, cloud computing, IoT, DevOps, artificial intelligence, and optimization algorithms. I welcome you, sir. Session is over to you.
Yeah, thank you, sir. Yeah. So shall I share my screen? Share ചെയ്തല്ലോ സൂമിന് ഷെയർ ചെയ്യണല്ലോ അല്ലേ join, sir. Join. The share option is not there. എൻ്റെ സ്ക്രീൻ കൊടുക്കരുത് എൻ്റെ സ്ക്രീൻ കൊടുക്കരുത് മറ്റു മാത്രം കൊടുത്തു പക്ഷേ ഈ ഉണ്ട് മാത്രം ഈ ഉണ്ട് ഈ കറക്റ്റ് വാട്സപ്പിൽ ഓപ്പൺ ആണ് ഇതുണ്ട് ഓക്കെ ഇതൊന്ന് right. Yeah. So hope I'm audible in online as well. So the topic is on just basics of fog computing and some of the applications. And if possible, we will also discuss how we can implement this with some basic hands-on. But everything I don't know how we can complete in 1 hour. So we will try our best. Otherwise, I will show you how we can realize it. So all are anyone is already working in this domain here? Nobody is. Okay. Anyone have heard about this edge, fog, or anything? So you are all which background, like UG or CSE UG background? Okay. PG also there. Yeah. Okay. So let us start with yeah. Yeah, let us start with Internet of Things. All might be already familiar what is IoT. IoT is nothing but it's like enabling the things to communicate with each other, right? So the things like what we are seeing in and around us, maybe a camera, maybe a TV or the smart board, the fans, if they can both, all of them can communicate with each other, then our works are very less, right? If, for example, before we reach, if the AC is turned on, or you can communicate with your fridge to keep your things to reduce the present temperature, or if you want to communicate to your washing machine to turn on its, and while you wake up the clothes are already washed and you can just put it in the outside, right, for drying. So like if the things are able to communicate, the things like it will be more easy, but at the same time there are a lot of things need to be, or other activities need to be carried out for realizing that, right? So nowadays the number of devices with us is increasing day by day, right? For example, I have a mobile phone which have two SIMs, right? Again, I have my laptop, I have my tab at home. Maybe I have a camera, I have a smart bulb at my home, which is at my native, so that I'm controlling from here sometimes. I can, so number of devices is increasing day by day, right? Previously, when it was maybe maximum of one, average of one. Now, can you imagine what is the number of devices in and around the world? Any idea? What is our population? Total population across the globe? Around 8 billion, right? So in that 8 billion, according to the Gartner, like who is pioneer in making the predictions and surveys and everything, they are predicting like around 3.6 to 4 devices per capita. Per person is having around on an average 3.6 to 4 devices. So 8 billion into roughly you can calculate into 4. And by 2050, they are predicting it will be more than 100 billion. So these 100 billion devices are generating a lot of data, right? But we don't want just data. We want some useful informations from the data. So what we want is we need some mechanism to process this data, right? We need something to process this data. The raw data is just useless, right? The data is there, but what we can do? We are not getting the required information. So what we need some platform for processing that. There comes first cloud computing. Okay, as a solution of that, they have proposed an approach which is known as cloud computing. Already you have gone through one or two sessions, right, in the cloud. The cloud is nothing but like a wide range of capacity you have with which you can use the required amount of resources which will process it and you will get the result back. You can imagine that one machine is there which is a little bit bigger, right? So kind of like you can imagine that which is a server here. Whatever you want, you are sending to your server and server is processing it and giving you the results back. A common example everyone used to tell is like your electricity, right? The electricity we are not generating, right? We are not managing, or we are not creating. It's created by, if it is Kerala, it is by KICB, or if it is in Tamil Nadu, maybe Tamil Nadu State Electricity Board, and so on. Different, even private parties are also there. But what we are doing, we are just using it, and according to our usage, we are paying it. So the same concept arises in the form of cloud computing, where computing resources you are getting and you are using, and after that you need to just pay for whatever you used. That's what you have seen in Amazon or GCP or whatever it is, AWS, or even in Azure, whatever it is. You can create an account, you can use it, and you need to pay it. That's it. So we have a cloud, and I told that it's having around infinite capacity, right? So it can handle this data, right? It can handle, it can process this data, it can get some useful information, right? Then why we need something called edge or fog? To reduce the latency. Yeah. So the cloud and IoT, that paradigm used to call it as cloud IoT paradigm together. But again, as you told, the problem was with the delay. So when delay increased, what the people used to think is, whatever be the device which generate the data, let it be capable of processing that. Right. That is the easiest approach. Suppose if this camera is generating that much videos, if that itself is processing and if it is giving you useful information, then that is the best thing, right? Are you getting? For example, you want to see only the visuals which having a human presence, or the camera should automatically detect the human presence, and you need to see only that video. Because if it works 24 hours a day, that much visuals will be captured. So even if it is a human who want to check the presence of any intruder or whatever it is, he has to see it completely. So that is difficult, right? So the people started to think, okay, let it process the same thing, and we will get some results back. So, but the problem is, we are placing these devices in such places, like in locations where we can't accommodate that much bigger devices. It may be either because of space issue, it may be either because of the power constraints. Because when the device capability is increasing, automatically its components will be increasing, automatically you need more power, right? You may have seen the camera which is there in this room. It's there, right? No, it might be there in the back side. But at the same time, you may have seen some cameras. Yeah, it's there in the back side. You might have seen. The camera is just capturing the images. Whereas there are some other cameras you might have seen which having little bit bigger size, which having all the capabilities of detecting the human presence as well as can even
ഇവർക്ക് തന്നെ ഷെയറിംഗ് കൊടുത്തിട്ടുണ്ടെന്ന് ലക്ഷ്മിക്ക് കൊടുത്തിട്ടുണ്ട്.
Yeah. Yeah, fine. So it's around 10:30, no? All are busy in and it's vacation, so kids will be there at home. So those who joined, we have to, yeah. So this camera, you can see the size difference, as well as the power requirement is also different. So we are using these IoT devices. For example, you are using this for detecting the fire in a Amazon forest. Or maybe you are using this for identifying some things in the ocean, under ocean. So those areas, you can't frequently change what? You can't frequently change the devices, or you can't constantly give the power. It may be battery operated, and battery also will be very small. So what I was about to tell is, giving the computation power completely to the end device is also not practically possible. So one is like cloud is not possible. One is edge also not possible. So again, why cloud is not possible? Because as you told, delay sensitive. So I just explained with one example. So you can see that this is a traffic system which automatically detect the number of vehicles and which will provide the signals according to that. So it should process very quickly, right? So if there is one vehicle, when it blinks green, in that moment, if some other vehicle is approaching some other side, it should give red in the other line, right? Otherwise, it will create a accident. So there are some scenarios where we need, like, I don't know how many of you are from Kerala. Anyone is from Kerala? Here, okay, one, two are there. Yeah, it's a clip from a movie. Like they are booking for a drama, and they are calling like when you will arrive to the destination where it should happen. But the people who has to play the drama at 5 o'clock also they haven't started from their location. So he is telling we are on the way, we are on the way. It's like that. But sometimes our decisions should be like this. This may be familiar for everyone, right? We may not be able to relay somebody so far to solve the situation, right? We need the decisions very quickly and it should be on time, right? So in that cases, what can be the solution? But at the same time, I told that you can't completely rely on the end devices. So as a solution, we have proposed something called fog or fog computing. Nowadays, we are interchangeably using the term fog as well as edge. But initially, we have started with the term fog computing. Edge was specific to end device capability. But now we are using both interchangeably. So fog is nothing but which is in between, which is not the cloud, which is not the edge, which is something lies in between. Okay, lies in between some means, is it something like a cloud is there in the top and we are placing something in between? No. It's like, you know that how the systems are connected to through the network. For example, when you are connecting to a cloud server, you are connecting through what? You are connecting through your network and it's outside your local area network, right? It's not in your local area network. It's outside your local area network and that is somewhere else. And from that, in between, there will be a number of networking devices, routers or whatever it is, and you will be connecting to someone else's network, right? But fog in this case, it will be trying to keep within our network maximum, and if so, also it may be one hop distance. Okay, so then only we can call that node as a fog node. So fog node can be anything. Like it will be architecturally, the structure will be something like this. This will be the cloud and this will be the fog. This will be the edge or end devices with some capability. Okay. So how many devices can be there? Again, this can be of not a single device or single layer devices like your cloud. It can be consist of a set of devices which are interconnected together. Okay. So now again the same things, how it is differ from the cloud, because without fog means everything should be transferred to the cloud, then you should get the data, whereas in this case you can see that it's some data are processing here and you are going to get the result. So if fog is there, can we replace the cloud? Anyway, we are going to get the results. Next question will be like that, no? Because we are going to get the results very quickly, either from edge itself or from the fog. Then why we need a cloud, right? So you can imagine an example like you are going to implement a fire alarm in a company or in an industry. You imagine that you are going to set up a fire alarm. So hope you all know that how a basic fire alarm will work, right? Automatic fire alarm means there will be some sensors. That very basic idea is let the sensors sense some temperature. And if that temperature is maybe above a threshold, for example, if it is above 50 degrees Celsius, then you are detecting, like you know the region. If it is not normal that 50 degrees Celsius is there, you can set that as your temperature. And if the sensor is detecting above 50 degrees Celsius, what we can do automatically, it can connect to a simple buzzer and it can provide a alarm. Right. This is very simple thing which you maybe nowadays in school students also doing the same. Right. So you imagine that if it is being processing in the cloud, this data has to be transferred to cloud, then it should get processed, then you should get the result back. But by the time maybe your organization may be completely burnt, right? So that is not a solution. So there we can use the edge or fog computing. Now, in such scenario, can I completely eliminate cloud? That was my question. So you imagine that you are storing the data for long amount of time. For example, for 1 year, you are storing like whatever be the temperature you are getting. And based on that data, if you can make some analysis, for example, in the month of March and April, there is a probability that like your company may affect according to the last few years, your company may affect a fire issue. So some warnings can be given. So for giving that warnings, what you want is you need to process your log or you need to process your data for long time. This is not only in this fire alarm case. In any domain, we are using the same. For example, if you want to, we are making the things like automatic pipelines and everything we are creating for our models like machine learning models or our applications, we are doing everything. So there also we are actually monitoring the logs for a period of time, and according to that we are making some kind of predictions. So what we want, we need to store the data, right? For example, maybe 1 year data you are going to store or 2 year data you are going to store. So you need that much storage capability. Then what you want, you need to run some high computational models, maybe ML models or DL models you may need to run for making the predictions. So those things, even if you are not doing in real time, there is no issue, right? Because let the data be stored there and model be run, and it's just going to give you a warning maybe 1 month before. So those things again we can do in the cloud itself, because compared to the cloud, fog and edge nodes are more costly. Okay, so cloud fog is not, and edge computing is not going to replace the cloud. It will work along with the cloud itself. That's what I want to tell you. Okay, so there are scenarios according to your logic you have to, or according to the requirement of the client, we have to decide which way we can go ahead. Okay, so now this is again some definitions from some of the textbooks. Yeah, like it's self-understanding, whatever the things I have already explained. So what can be your fork node? Like we have seen something intermediary, and I told that it's something between the cloud and this one. So what can it be? How you can realize it? Right, it's not an imaginary concept. It should realize with whatever you have. So this can be any device which having some computation and storage capability. It can be your laptop, it can be your router. Not all the routers, whatever we have used, doesn't have any computation capability. It's just do the routing process. But nowadays, even your Xiaomi, and even what else, Cisco, all are producing some kind of routers which having even some computation capability. So even that can act as a fog node. Your mobile can act as a fog node. even a Raspberry Pi, your device, Raspberry Pi based microcontroller, what we are using, that can be, and NVIDIA Jetson, which is very computationally capable one. We are also doing some kind of works with that. So all those can be your edge or fork nodes. Okay. So this is again a theoretical one. How the consortium is like, who will regulate? You know that if it is a communication protocol, usually IEEE is controlling the protocol and they are setting the like rules and regulations. Similarly, FOG is also having a consortium which is known as Open Fork Consortium. So they have defined some like basic architecture and how it should be. There should be enough security policies. There should be enough like cloud services, how it can be integrated, all those things. I'm not going much detail into this. So let us move on to some of the applications first. What these nowadays available like or being used, already used. Because with 1 hour, I'm sure that I can't completely cover everything, but I can create some interest on this subject so that we can further, you can go ahead. So this is an Olympics which held in last time in last to last time in like Tokyo, Japan. So this they have developed a 3D based mechanism with which placed in two sides of the track and which gives a 3D view of how the athlete is moving on. So they use the technology as what we call is 3DAT. So which is actually a collaborative work by Intel and Alibaba. So what it will give is which moment that let's increase the pace and how he is moving, a complete analysis. Even this can be used not only for the final like the Olympic, while he training also he can go ahead and he will get a details about how he is moving on. Then this is regarding the precision farming. This is produced by Sky Squirrel Technologies. They are one of the pioneers in edge computing form. So you can see that how it will completely monitoring the plant health. It's a drone which will completely analyze the plant health and will give insights on how this can be proceed further. Then similarly, one is you can see this. This will check whether the fruit is ripe or not. So those who are like we know that when somebody comes to pluck it, they may pluck everything, whether it's ripe or not. So we are using some form of robots which will check whether it is ripe or not. If it is ripe only, it will pluck it. Otherwise, it will leave it. It will allow to ripe it. Okay. Again, this is a news article from Karnataka state, from India. So they are planning to make like the city traffics mainly into a automated edge-based traffic controlling system. And one more is this is in India again now widely using Stellabs. Stellabs this is again a startup based firm, which actually what they are doing is they are using some edge-based sensors as well as edge devices for making in the all field of like dairy industry. So they ensure that your cattle are healthy and you are getting sufficient amount of milk, like with the help of, and it's processing near the cattle farm itself. Okay, so the farmers are getting a clear idea like how the things are going on, whether they are having, if it's reduced, they can check whether any disease is there or it's with respect to the food what you are giving, and all those things can be done. Then again, in the form of industries, we are using for, you may heard about the term predictive maintenance. So predictive maintenance is nothing but, I don't know whether you heard it or not. Predictive maintenance is nowadays is there in all industrial sector. So what it means is, suppose you have a number of machines and suddenly if one machine goes down, imagine a company which running with 3-4 machines. So one machine is suddenly goes down. So this may affect your raw material because your raw material may, some industries, raw material needs to be processed within few days. If it's opened, it may need to process within few days, right? And one more thing is your labors are waiting there. You need to pay for your labor, right? And you may be committed to somebody that you will deliver the order in so and so time, right? But unexpectedly, your machine goes down. So to avoid that, what predictive maintenance is, if you are using collecting the data about the machine, and if you are using some models to predict in such a way that the machine may require a maintenance on so and so date and so and so time, then what we can do? It is already scheduled one, right? We can decide like, okay, on after 2 days, my machine may require maintenance. So, or after 1 week, my machine may need some repair or something. So I can plan accordingly, right? So that is comes under predictive maintenance. Again, this is also doing with the help of sensors and analyzing the data. So all these are nowadays the research articles are also coming in different domains because the data sets are available in all these domains, public data set as well as those who are some are collaborating with specific industries and collecting their data and creating some models and making it to run in their environment. So these like in this field also a lot of research as well as a lot of application developments also going on. Now Tata Steel, then again one more steel manufacturer, I think Jindal or somebody already started adopting this predictive maintenance in their industry because they are dealing with maybe crores per day, right? So it's not like easy that if their machine or something is going a sudden shutdown or anything, they have to pay a lot. So those big giants already started adopting this, but as we believe that this will come in small industries as well in a low cost manner, and that is possible. Okay. Now, similarly, you can see that there are edge data centers are creating by different vendors. For example, Bharati Airtel, then Railtel, and even Jio also started creating some form of edge data centers. Why? Because, for example, if you are taking the Jio cinema, if it's getting streamed without much issues, you will subscribe in next month as well, right? But if you get it like very pathetic manner, that too with a Geo SIM, you will definitely you won't go ahead with that in the next month, right? So what they are doing is they are getting some setting some edge servers in nearby locations so that the movie or whatever it is will be streamed from those servers rather than cloud servers. Okay, so this way this will be helpful. And regarding IIIT Kottayam, we are also working on this domain. Some of our products are there. So this is actually one of our simulator, which is for digital twin as well. So it's for autonomous vehicles. So this simulator we have completely created by us, which you can load to the map of any cities, and you can decide like your vehicle, and accordingly it will like move on. So we have the research is going on. That's why I haven't included the complete details here. Like an autonomous vehicle tracking, like Kochi is also having an autonomous car startup. We are collaborating with them, and this simulator will help them to decide how their car will be moved in simulated environment. Okay, because this will mimic the complete like scenario. If you giving a snapshot of current map, this will act accordingly. Then one work which we have done is automatic bin selector, which is for like again for as part of clean city program. So where we have used some Raspberry Pis, that's edge computing Raspberry, like edge-based Raspberry Pis. What it does is like a number of bins will be there automatically, like according to the waste. Suppose you are going with a waste, because one of the main challenges is waste segregation. Wastes are there, but the problem is you will keep everything in the same bin. Whether it is a food waste, whether it is a plastic, whether it is a it's a glass, you are dumping everything in the same bin. So the main problem actually, we have technologies to process each of this waste. We have technologies to eliminate or we process each of this waste. The problem is it should be properly segregated. If it is a plastic, we have approaches to handle it. Maybe it can be used for tarring purpose. It can be used for like recycling of some plastics are recyclable. So the problem is you are putting the food waste along with that. Then who is going to clean the plastic from the food? So what we have proposed is, suppose one person is going with waste, this will automatically detect the type of the waste and corresponding lid will be open. You can place it in. Okay. So the lids will be connected with the pipe. There is a camera. The camera will detect the object. Accordingly, the lid will be open. The thing is very simple, but found it's useful for the community. Then next is we also developed an edge-based system, which is for training purpose of shooting. So what we are doing is we will identify the position, the hand position, the body position and everything. And with the help of the images, there is an edge device which will record the entire process. And accordingly, you will get the feedback. Like even if it is usually the problem with the challenge with the shooting process is, even there is a coach, it is difficult to correct him in the proper manner. So this, what we will do is, this will automatically analyze, maybe you are shooting for a period of time, and this will, our device will give you, we are using some edge models, edge ML models for analyzing it, and it will give you the positions and it will also give you the correction for your shooting positions. Okay. So next time when you hold your hand, it will tell you like, again, move your hand this much degree to one side. And if it is correct, it will tell you, yeah, now you are in correct position. So what we believe is after, with the help of this, if you are doing some kind of trials for a period of time, automatically we will be corrected. Okay. So these are some of the applications which we have done in the field of edge environment. And also I have shown you some from the international and some Indian applications and IIIT what we have done. Now, how we can realize it? Now, how we can implement it? So for implementing, you can use different strategies. One of the easiest approach is container virtualization. Okay. Then what do we mean by container virtualization? So container virtualization is nothing but you can deploy your application in the form of small containers. I will explain what it is. So what was there before this? I don't know how many of you are familiar. Those who are in my age might be 90s. We nowadays used to call 90 kids or 80 kids. They may know this lamp. So this was the tech, maybe by 2000 or 2005 and all. This is completely nowadays not using. LAMP is nothing but you have a Linux server, you have a Linux system, you have an Apache server, you have a MySQL database, and you have a PHP for your front end. This was the web application. So this was the common technology stack, LAMP or WAMP. LAMP will change to WAMP. WAMP means nothing but instead of Linux, it will be Windows. That's it. So what I was about to tell is, this was a common technology stack during that time. So whoever is going to build a web application, they can build with this particular one. But now the things are changed, right? Now it is not like that. Now a lot of opportunities or lot of options are there. For if it is a static website, you can either use Bootstrap or you can use Nginx and DB, either Postgres or maybe MongoDB or maybe Redis. A lot of DBs are there. And even for web front end, a lot of things, Ruby, Rails, a lot of options are there, right? And another thing is, it is not only need to deploy on a Linux or Windows server. It should be deployable on different environments. Like what I told is it should be deployed on a fork node, edge node, or maybe on a server as well. So that's why I told it can be on a QA server, it can be on a laptop, it can be on a cluster machine. So it should be deployable across different platforms. So your application is built with different technologies. Even a single application you can build with one module you can build with Java, one module you can build with some other maybe Python, one can be built with Go. So that is also nowadays possible. So how you can make it to deploy anywhere, everywhere. So this was a challenge for everyone. And this problem is known as metrics from hell. Because one who is about to deploy this, he may feel that he is sitting in a hell. Because he has to deal with all these technologies and it should be deployable on all these devices. Right. Yeah. So if you have, like if anyone is taken any internship on any industry, or if any one of you have worked in any industry, because I was like after I was in an industry for a period of time. So deployment is a headache. If you are any one of your siblings are working, they may tell that why you are late or why you are much busy nowadays. They will tell it's going for deployment or it's going for clients. So that time means it should be up and running and it should be accessible to your client, right? So the problem is one who create it is not the one who is going to deploy it. So you may forget to, because suppose if I created an application and if I am giving to him to run it, it may not run because it may have a lot of dependencies. Maybe I created in Windows, he may trying to run it in Linux. Maybe in Linux itself, I created in a different version and my libraries may not be same what he have already installed. So it may give you some form of errors. That's why this problem is known as metrics from hell. Okay. So for solving all this, in earlier time itself, this problem was there for transporting different goods from one location to another, because there were different things needs to be transported and it's having different shapes and size. So they have come up with a solution, nothing but your normal container. So this was the solution they proposed in ships and all. How they can, because you know that earlier times it should be transported from one country to another country through ship only. So they proposed container. So the same strategy, you know that the computer science people, we are very good in adopting the good things from the other domains, right? You know that machine learning and deep learning models, what is that? Everything is mathematical model, right? So actually those are who are brilliant in mathematics, they develop the models. What we are doing, we are just taking it, we are using it, and it become our own computer science, right? So similarly, we have taken a lot of concepts from different domains. One is this one, container. So what we have done is similar to this, we will be packing everything together, like for an application, whatever things you want. If you want for running that application, if you want Postgres database, if you for running that, you may need JDK 11.6 or maybe any other version. Everything will be packed together and that will be sending to somewhere, and there you can run it directly without any hurdles. So that is what we call containers. So in computer science, what was there before this? It was containers before. Containers just started in the year of 2013 or 2012 to 13. It became popular. So what we used to do before that for transferring? So that were like binaries. I don't know how many of you are familiar. Previously, we used to copy the software in a pen drive. Maybe it's an exe file that we will try to run it. The problem is it also will be having maybe some DLL file missing, some issues used to come. Another option is you can use virtual machines. You install everything in, maybe you are familiar with virtual machines, right? You install everything in a virtual machine. That virtual machine as it is, you can give to somebody else because you can export it as in a file in such a way that it can be run in different environments. So, but the problem is the VM is very, very heavy because hope you have already installed virtual machines before. So you know that you have to load your entire operating system into the virtual machine. So it is very heavy and shipping is also very difficult because you need to transfer that much amount of data through the network. So there comes as a solution that our containers. So you can see that virtual machine means it's having an infrastructure and a host operating system and a hypervisor above that. These many guest OS will be there. These are the virtual machines. Each one will be having again operating system and above that you are running your application. But in this case, you can see that it's having a common operating system. The kernel is shared with everyone. So of course, there are more security issues than this one. Okay, even though it's advantage. So you can imagine that in a laptop, do you know how many virtual machines you can spawn? Without any without much making the laptop maybe in such a way that you can freely use it. Maybe 2, 3, maximum 4, maybe if your machine is that much. But in the same machine, you may be able to spawn hundreds of containers without any issue. So that is a scale difference. Okay. So that is a need for containers, but at the same time, it's sharing the same operating system. Again, this containers itself is a big topic that needs to be covered in maybe half day is required. Why it is that much required? Then, so basically, it's nothing but you are going to package everything together. For example, your operating system is Debian and you need Java and you need a Tomcat server for your application. So everything together, you made it as a container. This you are going to move to one location or you are going to ship from one location to another. Okay. Now, again, it's a bit more details about the structure of containers, how it works. Like it will be having a same kernel, but process ID, network, and mount everything will be different. Like even I don't know, you may know that in an operating system, in usual manner, no two process will hold the same process ID. But in this case, even the container will help you to create the process ID for each of the sub process separately. Then, yeah, next is how it is working right now. Whether there is any whether containers will replace the virtual machines or not. The answer is no. Usually it will, yeah, I need to explain a lot. But again, yeah. So what it does is usually if you're taking Amazon or if you're taking GCP or whoever it is, the cloud providers, they used to use both coexist together. Why? Because the issue with the containers is, as I already told, it will be able to running on the same operating system. Maybe there will be applications which need different flavors of operating system. But if you are using only containers, that is not possible. The next thing is the number of processes which we can support on a single OS. There is some limits that with respect to the OS based one. So that will create again some problems. You may know that you may have found that during the festive season, if you're accessing any or during the result announcement, when you're trying to access some website, it used to get hanged, right? Why? Because that is not able to, there are no that much number of processes available to cater your request. So if you take containers, advantage is which will automatically spawn new instances very quickly and it will cater the needs of the user. That's why even Diwali festival, if it starts, big billion days and all comes in Amazon, Flipkart and all. Nowadays, you are not experiencing much delay. Why? Because previously they used to use virtual machines. So for spawning a virtual machine, you have to spawn this entire thing. You need OS, you need your OS, you need your everything. Then you need to create a new one. So which will take minutes in terms of minutes. Whereas spawning a container, it will be in terms of seconds. So that's why nowadays you are not experiencing that much issue in all the domain. But again, we know that like even though everything is scalable, there are some limits because it will also depends on the physical infrastructure, whatever is available. For example, if you have a 16 or 8 GB RAM machine, you can expect the performance maximum up to 8 GB, right? You can't expect something like 32 GB or 64 GB RAM. So similarly, like this issue is still there, but up to an extent, these all issues are now solved with containers. Again, when you need different flavors of OS and all, it is better you can make it together, create a virtual machine, in that spawn a number of containers, again a different OS, again you can spawn a number of containers and so on. Okay. So now, like it's kind of, we used to call it as Java applications or Aura, write once and run anywhere. That is usually we you call Java because Java virtual machines can be run anywhere that they claim. But still it's also having, even if you are using a enterprise edition, still it's having some issues. Those who use Java, they can, like it's having some dependency issues. But regarding the containers, it's used to call it as PODA, that is package once and deploy anywhere. Package once instead of Vora, we used to call it as PODA. It's package once and deploy anywhere. So that can be deployed anywhere. We will try to see one of the applications. So in a container, there are two concepts. One is image and one is container. Image is nothing but your your program. And container is nothing but your process. So what is the difference between a program and process? A program is just piece of code, right? But a process is nothing but a program in execution. So similarly, your image is nothing but it's just piece of a code. That is your image. Whereas your container is something which already started running. Okay. So this is also like used in DevOps. DevOps also, the base of DevOps is again the containers, because there also we are transferring the code from the developer to operation team using the containers, which makes the collaboration more easy. Now let us like Docker image, Docker container. Docker engine is nothing but it is actually the base of your, like you have seen in the architecture, just like hypervisor here, what we have is Docker engine, which manages this one. Okay. Now I'm not going much detail. Let us try to run one container. So there are two ways which you can do. Yeah, there are two ways which you can do. Either is you can install the Docker install. If you give, like you will get install Docker engine, like one way. If you have laptops, you can take it. I will show you to run one or two images. So one way is you can directly install. While installing, I will tell you one thing. Just select it and you can choose your particular operating system here, whichever is your one. If it is it's available for Windows as well. Windows is actually the support is providing by Windows WSL. That is Windows subsystem for Linux. So that is available from Windows 10 onwards. So if you are using Windows 10 onwards, 10, 11, everything is having that. So it's actually running in the Linux kernel, but that Linux kernel is underlined and Windows will provide you the service. So if you are using Windows, there is an option called Docker Desktop, which you can install. If you are using Linux, you can directly install from this. And for example, if it is Ubuntu, so there are three ways for installation. So installation methods you can see there are three ways always. So out of that, like I used to prefer the last one, that is a convenience script. So the advantage of convenience script is the other one is all the steps you have to manually install. Whereas if you are using the convenience script, the advantage is they created a script for you already. You just need to execute these two lines of code. Okay, I'm not installing now because this is Windows and my machine is already installed. You can, if any one of you is trying, you can just try these two lines. If you are not feeling that it's not to be installed, there is another way. You can check play with Docker. It's available in the browser. So if you go with play with Docker, yeah, again, network is little bit slow. So there is an option which is called login. There you can select, there is an option called Docker. So once you select it, it will ask you either you can, like if you have already an account, you can sign in there or you can sign up. Just need your mail ID. Okay. So that you can check it there. You can just give a sign up there. So you will get you will be allotted a machine which in already installed Docker. Okay. So anyone is able to sign up? If you have already installed Docker Desktop, like you will be able to see this Docker Desktop will be running in background and you can use your shell. Okay. If you logged in the play with Docker, there also you are getting a terminal like this, right? So you can just type Docker first. So if Docker is already installed, you will get some set of instructions how you can use the Docker command. Otherwise, you may be getting an error message saying that Docker is not installed. So there you can try. First one is either Docker version. Okay. So when you try Docker version, you can see that it's mainly having three parts, three components. One is the client, one is the server, and the server itself is containing the registry as well. So here in this case, you can see that the client version is 27.2, that is updated one. And the Docker engine, whatever we have seen, it's also having the same version. So this is both are installed in the same machine here. Even you can install this in two different machines. Okay. So now we will try to run one any one image. So for example, let us try with hello world. So whenever, if you want to run any image, one way is you can just search over the for example, you want to run an image. This is a base image, Docker run hello world. If you just type on your browser, so this will give you this will redirect to your Docker hub. Okay, Docker hub is nothing but it is a repository where you can store all the Docker images, kind of a place where you can access the image, from where you can download it and from where you can use it. So suppose you want to run a Postgres database. Suppose you want to run a Redis database or whatever it is, or you developed your application and you can Dockerize it. You can run it on any of the environment. So you can see that here there is a command in the right side, Docker pull hello world. So what you can do is you can just copy it. And instead of pull, I am using Docker run hello world. So you can see what happens in the first line. First line is saying that unable to find the image locally. That means when I installed and when I checked the Docker version, I have shown you two parts. One is your Docker client, one was your Docker engine. So in the Docker engine, there is a local repository. Just like Docker Hub is your remote repository, you have a local repository where your local images will be saved. Okay, so first it will check with your local repo whether that image is available or not. If it is available, immediately it will run. Otherwise, it will pull that image from your remote Docker Hub, then it will add to your repository, then it will run it. Okay, so now you can see that it's giving, yeah, what was our image name exactly? Yeah, now you can see that it's trying to pull the image with the name hello world using default tag latest. That's why it's taking some time. It's through, since our network is little bit slow. Yeah. Yeah, can you try this command in your Docker, in your play with Docker? If anyone is trying, just try the command Docker pull then hello world, hello-world. So if anyone wants to learn this, the advantage of this is Docker is providing a detailed. Anyone got any response? Anyone tried? No, it's not running. Not need to install, just try on the browser. Play with Docker. In that, you just create an account. It just need your mail ID and try to run at least one command. Just go to the play with Docker. Because in mine it's already installed. But installation may take some time. So that can be done in like with 1 hour session. So what you can do is you can just go to the browser and you can start on just create an account. It just need your mail ID. That's it. Sign up option you can give. The advantage is same you can use for your Docker hub as well. So how it is connected with Edge is like, yeah, because my time is going to complete. So whenever you are developing an application specifically for Edge environment, what we used to do is we used to containerize the application. Whatever the application we built, it should be in lightweight. We will containerize it such a way that it can be run on any of the heterogeneous Edge or fork devices. So that is the reason how these both are mutually connected. So in order to develop an application to run in Edge environment, you should also be able to, not in the simulated environment, in the actual environment, if you want to do it, you should also be able to containerize it. So you can, what you can do is there are different websites are available, like the basic Docker commands. I will show you one. Yeah, if you go for great learning, you can see that top 20 essential Docker commands. So even I can also share with you. So what you can do is, because now we don't have time, but what you can do is I have already shown you that console. In that console, you can try these commands: Docker run, Docker ps, Docker stop. They have already detailed what each command returns. So just go to the play with Docker, and first you try to run one image, Docker run, for example, hello world, that you try to run. Once it's run successfully, then you go ahead with trying at least some 5-6 commands, so that you will at least an exposure you will get. If you found it interested, you can go on that. Docker docs is one of the best reference. No need to go ahead with any other unnecessary documents, because Docker is having a very good documentation. Okay. And if any queries or anything is there, even you can reach out to us also. We can also help you, because this itself will take a lot of time, but I just tried to give an overview and an interest on you so that you can continue on this. So this play with Docker, there is some restriction regarding the timing. I think 2 hour or 3 hour only they will allow. But again, you can create a new machine if you want. So you can like use it for a long time, but I won't recommend it for a like persistent or continuous storage. Suppose if you are planning to host an application, or if you, for example, if we take we know that we have some GPU facility here. So what we used to do is, those who are interested in research, those who need high computational capability, even if it is a UG student, we will allocate one container for him. Okay. So that container is from our GPU. We have A100 and H100 here. So from that, we will allot one container to him. So he will be able to access the GPU from his laptop, but it's running on our GPU. The container is actually running on our machine. So the problem is, if he is not taking the backup and everything, what will happen is once the container is stopped, these containers are ephemerals. That means it's just like your ROM. Immediately everything will be vanished. It's not storing anything. Okay. So we have some mechanism for doing that as well. Similarly, when you're doing play with Docker also, suppose you installed an operating system. Next time, whenever you are opening your browser, they are not storing anything. You are going to get a new container. From your same account also, if you are doing, you are going to get a new container. So don't be worried like I have already installed these things, but now it is not there. It's like that. So if you want to use your own, better you install it. You create like you run a container. You can even take a snapshot of that container and you can keep as a backup. Okay. So even if you want to run a Redis database, the command is just docker run Redis. If you want to run a Postgres database, the advantage is just run docker run Postgres. Okay. Otherwise, if you want to install a database, there are a lot of dependencies, right? Those who try to install yourself, you may know that. So this makes that much easier and it is more comfortable for everyone. Okay. So just some overviews only I have given. Any queries or anything? Or if at least anyone feels that, okay, we will try to start it from your end.
Sir, then I have one more doubt, sir. As you said before, means this Docker is like means edge computing is like middle between cloud and the end devices.
Yes.
So if you collect in a scenario case, if you are collecting more number of datas to keep it backup, should we transfer the data from edge to cloud, or it will be remain in cloud edge itself, sir?
We have to back up in the cloud because the capabilities, as I already told, it will be probably limited. So if it is not required, for example, if some cases I already told, you may not need a real-time answer or you may not need a real-time response. Response is a better way. So if that is not required, better is always stored in the cloud so that it will be safe and secure and you can store unlimited amount of data. Whenever it's required, you can like the decisions can be taken either from the cloud or from the like accordingly you can.
So like it does edge computing of fog computing is similar to cloud, means like we have.
Yes, almost similar. The thing is the different is the main challenge is here it consists of heterogeneous devices. Cloud more or less like it's maybe high computationally servers and it may be homogeneous nowadays. But this can be either as I already told, it can be a router, it can be a laptop, it can be a mobile. So how these all will communicate and it will act as a cluster or it can act as a single computation power to the customer or for the clients. So there exists a challenge and there are a lot of research works also going on in this.
So does this as something like availability zone and similar to cloud computing?
Right now, public availability is very less because each one is creating their own for their own purpose. As I already told Railtel, though everyone is creating for their own. Right now, publicly not much available, but a lot of CDNs are available. Content delivery networks are there where there are some edge servers are there where we can push our data. Even the public subscribers like Airtel and all what we are using nowadays, they are started to use the same.
Because if an organization is means you're having an IoT device or any kind of service, we are trying to means access their services. They have only a particular number of availability zone in particular region.
Yes,
but
exactly.
everybody cannot access from far away. So
Yes.
still we are facing latency problems over there now, sir.
Yes, it's just now also it's in the stage of infancy. Hope within maybe few years, like public cloud platform, some public fog or edge environments also will be available. Now even IISc and all they have a dedicated lab, like they have a dedicated facility. It's providing by Dreams Lab, so they have made it available to their community. I guess so. Hopefully, maybe like that something will come a miniature may come to a into fulfillment later.
So then one more doubt,
The
sir.
challenge is regarding the security as well as this heterogeneity, and it should be available near to the customer. So that's why it's going more specific to some specific clients, because somebody is setting up something here and we don't know whether it will be really useful or those things. So financial viability also need to be checked, right?
So I have one more doubt, sir. As many of them saying that Docker should be run under Kubernetes, or else it won't be that.
Kubernetes, yes, it's not comes in this topic, but I used to take sessions on DevOps as well. Kubernetes is nothing but it's actually, as I already told, you can spawn hundreds of containers, right? So when you spawn hundreds of containers, there should be something which should manage all these things, right? As I already told, Amazon case, I told, like when the number of requests is increasing, I told that the number of containers are spawning more, right? So somebody should detect that there is increased number of requests and automatically it should scale or it should spawn new instances. So Kubernetes is one of the container orchestrator. We used to call it as orchestrator. So that will manage everything. So it is not manually we are increasing the number of instances. When the number of requests is goes beyond maybe 25, the Kubernetes will detect that, and we may be already we can set some thresholds or some policies on Kubernetes scheduler in such a way that it should automatically spawn new instances. So similarly, not only scaling, Kubernetes is having a lot of advantages. So it is a basically orchestrator for orchestrating all the containers.
What about security in Kubernetes, sir? They are saying it's the main agenda for using Kubernetes. For security.
Kubernetes, the security issue is, as I already told, the base is container. So containers, as I already told, it's sharing the same kernel. So there are some basic level of security issues were there, but nowadays it's getting resolved. In the beginning, when they started in 2012 and 14, it was prone to side channel attacks. Side channel attacks in the sense, suppose you are running 3-4 containers on same machine. Through one container, he was able to access the next one. Okay, but it's a serious attack because suppose you and me is using Amazon Cloud, you are able to access my all data means it's a big problem. But nowadays it's getting reduced, but still compared to the virtual machine, the isolation which provides the container is less.
Thank you, sir.
Sir, does fog nodes any security architecture? Sir?
Which one?
Node. You said intermediate node, like
Intermediate node. Yeah, fog node.
it has any different security architecture to protect
Yes,
data?
that is also, as I already told, I told no, it's heterogeneous nodes. Heterogeneous means different types of nodes. So communication also will be a problem, like because this security issue can come in any aspects, right? It can be through the like if the node itself is vulnerable, it's a problem. Again, between the communication also, the intruder can create some issue, man in middle kind of things that can be done. So these all are really a challenges in this environment. In the that is actually there in the distributed computing environment itself. When you are connecting, it's when you are accessing a single machine, and if you are creating a cluster with some 5-6 machines below, we have a lab which having the cluster. So both are different because this will be more secure because you are using a single machine, your application is deployed there and it can be accessed only through that. But at the same time, when you are connecting 10 machines, it having some security issue, right? Network issues and everything is there. Imagine those 10 devices are 10 different devices. Again, the challenge is increasing. So there are researches are going on and there are different approaches are using. One, like as usual, one easiest way is making the data secure so that even if it is accessed, he cannot do anything with that. Similarly, another approach is making it more like the security mechanisms more tightened. So that is also another research area where research is going on. Still, its issues are there.
Thank you.
Any more doubts, offline participants? Sir, online we have some. Towards the online participants, you can unmute and ask if you have any doubts. Sir.
Thank you for the session, sir. Sir, I have one doubt, why we need fog node when we are using Edge? I mean, Edge can communicate with cloud, right?
Yes.
And now when you said how we differentiate Edge and fog?
Yeah, a very good question. So I think this was the question, first question being asked when I attended the interview here. Basically, as I already told, Edge started with a synonym like your computation capability is shifting to the end device, the device which generate the data. So that why it is known as edge computing, because it's towards the edge of this. But later the fog came, but what happened is people used to use this interchangeably in such a scenario, like some people started to tell like edge is not the device, it's the end of the network only. So which is apart from the network somewhere else. So nowadays actually which is using interchangeably, but still fog nodes can be 2-3 hops above the end devices. Like you know that network is not a single connection. So there can be like 2-3 hops above also, we will consider it as a fog node. Whereas cloud will be, the communication will be much more. That's the difference.
Sir, but when Edge becomes server, how it will communicate? Like how is the connection?
Edge
like
becomes-
you mentioned, like IoT device will be
Yes.
there and it is connected to the Edge, and then
Those
it
servers
goes
are
to
actually, we can also call as fog nodes. If you are using a server in the edge device, we can also call it as a fog node.
So Edge and fog, we can use it interchangeably. that is what-
Interchangeably nowadays is using. If you
Yes.
see the research papers also, you can see that both are interchangeably using. But it started with that differentiation was like this in the beginning, but people started to use both interchangeably. But still, that's what I told. If you keep 1-2 hop above also, that will consider as a fog, but usually that we won't call it as a edge.
Sir, one more question is container. You said we are using containers in fog edge and in cloud. So same containers, right?
Exactly.
So how we can migrate the containers between these endpoints, like for cloud to fog to edge?
Container migration is like if you are the devices are already connected. For example, 2 machines are already connected. You can migrate it with the help of, as I already told, there is something called Docker Hub. So one way is you can use the Docker Hub. You just push your container to the Docker Hub. From there, you pull it into your new machine. That is the easiest approach. One other approach is if the image is ready, that image is actually a file. The file you can use any, for example, if you want to push from one machine to maybe Linux, Raspberry Pi or something like that, you can even use simple Linux copy commands for copying that.
Okay, sir, one more question.
Yeah.
So when the load, like Edge, we know that very less computation power and everything. So when the load increases, like data increases, the container that is hosted in the Edge cannot be able to run. I mean, that cannot process the data, right? At that time, it will migrate to fog or edge cloud, right?
No, there are two things. Like there can be two reasons. As I told, for example, an application's one instance you have placed in a container, and maybe more number of requests is coming to the same instance. You may need to spawn new instances.
Okay.
So if that is the case, you have to spawn new instances of the same container. Right, that is one thing. Second thing is, suppose an application is running and its requirement is getting increased. So if that is the case which you asked, the container, there is an option called we can set the limit. So up to the limit, the container will expand.
Okay.
But beyond that, if the resource requirement is coming, it will go for throttling. Throttling in the sense your performance will be completely degraded. Okay, so that is also another research issue, like the scheduling and all. When people are scheduling algorithms and all, people are developing, they need to consider this as well. So some cases people won't set the limit. So there the problem is it can throttle other container in the same machine as well, because this will take the resources more than whatever is for example, you already running 4 or 5, maybe one will take 70% of your uses because the request first came there. Then you imagine that the second one is getting more requests, but second one is not getting enough resources. Got it. I hope you know the scenario because you're already working in this domain. So that's why we are actually some orchestration mechanisms we are using, and we are setting some limit, and even we used to call resource limit as well as resource resource request or something. Two terms are there. Both we can set.
Okay, sir. Thank you, sir.
Yeah. One container. Yes, we can. That's what we are actually doing. For example, if you are taking, I'm again taking much more time. Okay, fine. I think I can answer. So, for example, if you are taking Uber app, so Uber app is having different modules, right? One may be your booking, one may be your payment, one may be your what else? Ride checking, and so on. So what we used to do, morning we will check Uber, what is the cost from here to my office. You will also check that in Ole. You will also check that in maybe in Rapido, whatever it is available. And what you will do, you will also check which will come first, what time I will reach. Based on that, you are going to select one. So the number of instances which are required for browsing is more, but that many number of instances is not required for booking your ride. Right, are you getting? And again, after booking, you may cancel it sometimes. So the number of instances required for payment is less than booking. If number of search is 1000, other one will be 500, next one will be hundreds. So according to the requirement, you can create any number of instances automatically with the help of Kubernetes. Yes. Paying is one instance. That is, you are running in one container. That's what. That can be any number of instances you can spawn. The payment itself can be 10 or 100 instances. That will do, the Kubernetes will do that. Yes. Kubernetes is there, Docker Swarm is there, other orchestrators are there. Out of that, the most popular one is Kubernetes. It is by the Google. Okay.
Hope all the doubts are
If any
cleared.
further things are there, you can even contact me. I'm available here, or even you can reach out me through my mail ID or with my research team. Many are there, so you can. No issues. Thank you.
Thank you, sir. On behalf of the organizing team and all the participants, I extend my heartfelt thanks for sharing your expertise with us today. Your insightful session on fog and edge computing and the various research aspects has certainly deepened our understanding, and sparked new ideas for exploration. Thank you once again, sir, for taking the time to be with us and for your valuable contribution.
Yeah, thank you, Silambarasan sir, for giving a chance to interact with all of you. And if anything, if anyone want to work on these domains also, any kind of research work, or if you want to do some kind of works, we are open, even with respect to DevOps, the cloud, even in this edge containers, all these domains, we are the entire distributed computing domain. Our research team is working on that. So if you want any kind of such helps or any kind of any collaborations, you can reach out to us. We will try to help you the best. Okay, thank you.
So we are going to have a 5 minutes tea break. Then we'll resume our session at 10 for 11 10 for 11:45 itself. Okay. To welcome you. We are privileged to have with us Dr. A. Balu, Assistant Professor in the Department of CSE Cybersecurity at IIIT Kottayam. Sir brings with him 20 years of teaching experience and 5 years of dedicated research in the field of applied cryptography, focusing on pairing-based crypto systems and learning with errors. His contributions have been published in reputed journals, and his innovative work in laconic cryptography aims to enhance the efficiency and scalability of cryptographic protocols. With prior experience at prestigious institutions like NIT Trichy and NIT Calicut, he has made significant strides in both research and teaching. Today, sir will be enlightening us on the topic homomorphic encryption in the cloud, a crucial area that addresses secure data processing without compromising privacy. Let's all extend a warm welcome to Dr. A. Balu and look forward to an insightful session. Over to you, sir.
Thank you, Ma. Thanks for your introduction. Whether I have to stand here or there. Okay. So, welcome participants, those who are present in the offline mode as well in the online mode. So, welcome to this session. And my topic is homomorphic encryption and in the cloud. So, this is the topic. So, I want to take from the fundamental, and I gave this is nothing but it is the effort of 6 research papers that that is identified, and the application can be brought to the particular presenter for this one. Okay, and so this is my agenda. So I have to introduce what is that is homomorphic encryption and the variants of homomorphic encryption and the security standards of homomorphic encryption and the applications. So this is the agenda for today's session. So what is homomorphic? We can start from the word called homomorphic. You might study it, but this particular name in algebraic structure. Okay, whenever you come across to see, that is what is in the group, as well as if you have a group structure as well as a ring structure, there you have to identify the homomorphism. So what is homomorphism? Homo means same. Okay, so morphic, so it exhibits the same structure.
Hello.
So homomorphic means the same structure it exhibits. Okay, so for example, this is the literal definition for a homomorphic function. Okay, so if G is a group with asterisk is the binary operator and H is another group with delta is the another operator, binary operator. And a mapping f from G to H is said to be homomorphic if f of A star B equal to f of A delta f of B. So this is the point that they take the idea, the inspiration. So that is the encryption. The crypto scientists find the encryption, that is idea, from this fundamental definition. Okay, so how they inspired by this one and how they take it to this one. So what I say means G is a group with this binary operator, H is another group with another binary operator. If F is a map, that is A comma B belongs to G. So we have to take, that is as per the thing, small a comma B belongs to G. If I apply this operator A star B, for example, for asterisk operator, if I put plus, okay, if I take 2 comma 3 as a particular example, if A belongs to a group, integer group, means if A is nothing but 2 and B is nothing but 3 and asterisk is nothing but plus. If I do the normal operation with what will happen, that is 2 plus 3, 5. What is the mapping of 5? So this I can go for it. So here I can write, shall I write it here? That is A comma B belongs to G. So f of A comma B, that are A star B. So this is the thing, f of A delta f of B. So this is the thing. If I take A equal to 2 and B equal to 3 and binary operator, this is the binary operator equal to plus. If f of 2 plus 3. So what is the left hand side? F of 2 plus 5, that is I can write it as 5. For example, if this is the group. So 1, 2, 3, 4, 5, like etc. And this is another group, some 7, 8, 9, 10, 11, 12, like this. Okay, if what I have written in this one, f of A star B, that is f of 5. What is image of 5 under this one? If I say 11, the image of 5 equal to 11. The same thing, if I find f of 2 equal to some, in case if I don't have a number, I can write it just for example, f of 2 equal to 7 and f of 3 equal to some 4. Okay, and here also the same addition, f of 2 equal to 7 and f of 3 equal to 4. Okay, and if I go for f of 2, that is the delta operator is also plus. If I go for this one, then I can write 7 plus 4 equal to 11. Okay, so what is the image of 5? 11. This is a simple definition. They inspired by this definition, then they say. So what else may be the operation doing in this particular group? With this operation, the same thing we are going to do with the image. This is nothing but image. This is nothing but elements. This is nothing but the image. The image of 2 is nothing but 7. The image of 3 is nothing but 4. What else you do with this operation will be reflected in the same thing. Okay, so what else you do with these two elements will be reflected in this one. That is the idea of homomorphic encryption. You do something here, that is the same operation will be carried out in that particular one, 7 also. Is it clear? This is the basic mathematical definition. The crypto scientists inspired by this definition and they take over to the homomorphic encryption. So now I am going to say what is homo means same. Okay, what else you are going to do in the encrypted form, okay, as well as in the plain form, both are going to be same. So that is the idea. This is the definition. And by that, I'm going to say, this is the definition. What is homomorphic encryption? So what is homomorphic encryption means? So if you do encryption means, for example, M1 is nothing but that is a text. M2 is nothing but another image, that is another text. Or it may be the message. M1 and M2 are the messages. Encryption of M1, maybe I can write C1. Encryption of M2 is nothing but C2. If I do encryption of M1 plus M2 is nothing but that is encryption of C1 plus C2. Both are same. Are you able to understand? That is the group, that is the idea. So this is the message, this is the original message and this is the encrypted one, or you can say it is nothing but this hypertext C1 and C2. What else you want to do with this one? Encryption of EM plus M1 plus M2 is nothing but E of C1 plus E of C2. So same thing. The same definition I'm going to carry it out. Therefore, we are going to say that what else you do with the plain format, you are doing some operation. The same thing if you do with this hypertext also, it won't be affected. So for that, I'm giving the justification, the reason. Is it clear? So what else may be the thing? For example, if this is the, so if this is the, that is granules, that is, for example, there are two types of, that is a tablet, you can take it. So tablet may be the solid form that you can consume, that is swallow it. Other one is nothing but capsule form. Some granules will be there. Okay, some granules will be there that will be put up in a particular, that is with two type of, that is in capsule. That is nothing but capsule. Within the capsule, they will put it. Okay, what else may be there? That is, this granules will does the same operation, even though if it is put up in a particular, that is capsule like this. Same thing. Are you understand? I'm giving a general example. The granules will does the same operation, even though if it put in the another format. If you say the granules are put up in a particular capsule, means it will be encrypted. Even though it is encrypted, it will does the same operation. Okay, so for what purpose it has been encapsulated? I cannot carry the that is granules. It can be, if I put it in my hand, it may wasted. Okay, the medical property may go wrong. Therefore, it can be put it in a capsule. Then we swallow it. The same effect it is going to be. It automatically dissolved in the water, so it does the same operation. That's all. So clear? I gave 3 different explanations for why it is named as homomorphic. Okay, encryption means that is from the beginning itself, we said it about what is encryption. Some plain text is there. If you go for the encryption algorithm, it will be converted to some ciphertext. That's it. If you do anything, that is, are you able to understand the difference? That is, you can correlate with the thing. So both are going to be the same. What else you are going to do with the thing? So encryption scheme that preserve the structure of the operations. That is the yeah. So this is the introduction. Now you can understand why they named this homomorphic encryption. So simple encryption will provide what it provides. What are the cryptographic pillars? What are the cryptographic standards or cryptographic securities? If you encrypt something, or if I do some cryptographic, so if I do something, that is, if I does something, so what are the things you can confer, that is confer? What are the 4 pillars of cryptography? Confidentiality, integrity, authentication, availability is nothing but CA standard, authentication and non-repudiation. So these are all the 4 main pillars of cryptography. If I encrypt a message, then whom else possesses the particular one can view the thing. So that is for the particular person. That is confidential, can be maintained. Okay, confidential. For example, that is okay. So let it be. So the confidentiality can be maintained. So what else can be extra thing can be that is, it is augmented by homomorphic encryption. So it will does something other than the normal, that is encryption. It will, that is, it will substantiate. That I will come to you later. What the that is, what all the cloud security features. That's, I stick on to the cloud security features. It is nothing but the crypto features that will be substantiated by the homomorphic encryption. Other than that, the thing. So that alone I elaborate this one. So we can perform certain operation like addition or multiplication in the encrypted data. When you decrypt the result, the same thing will be happen. The same thing. This is the explanation. So you can do the addition operation or multiplication operation with respect to this one. Okay. So now I begin the concept with the help of an example. Every encryption, we need a secret key. I need a public key or secret key, whatever it may be. So by running this particular statement, this line, I'm able to generate a key. Is it clear? So let's get about the thing. So now we can encrypt some very secret data. Now I am going to do So this is the encrypt is nothing but the function. I'm going to encrypt the data called phi using the key. Okay, the encrypted data will be stored in the name of encrypted file. Is it clear? I took first, that is first I generate the key, then I'm going to that is encrypt the data called phi. That is stored as, this is the ciphertext or encrypted file. Next, I'm going to encrypt the data called 12. That is stored as encrypted form. That is nothing but encrypted 12. This is the ciphertext. And third data. So I'm going to encrypt 3. So how many data I am encrypted here? 3 data. 5, 1, 12 into 2. Using the, that is using the, that is my encryption key, I'm going to encrypt it. Okay, so this is the original one. 5, 12, 2 are nothing but the original one. Okay, so these are nothing but the, that is, so 5, I can write it as M1, M2, M3. Okay, this I can write it as C1, C2, C3. Is it clear? Is it clear now? The thing is, now, if I want to do, if you do like this, okay, so if I multiply 5 into 12, what would happen? If I multiply 5 into 12, what will happen? What in case, so I said that is only addition and the multiplication, 60. So the same thing, if I multiply C1 and C2, that also provides 60. That is the meaning of homomorphic encryption. If I multiply, that is C1 and C2, that also gives 60. Is it clear? Are you comfortable with this one? This alone, I'm going to prove it with my own example. I'm going to prove the systems. Is it clear? Now I am going for this one. Okay, so now I go for this one. So now I have 3 ciphertexts, na? 3 ciphertexts. We want to sum up the first 2. If I add these 2 things, what will happen? 5 plus 12. So 5 plus 12, what will happen? So 5 plus 12, what will happen? 17. Okay, so 5 plus 12, 17. If this result is multiplied by 2, what will happen? If this result is multiplied by 2, 17 into 2, what will happen? 34 will come. Clear? So this alone I'm going to explain. So if I add 5 and 12, this is nothing but the ciphertext. This is nothing but ciphertext and this is nothing but ciphertext. I'm adding the ciphertext. This is stored here as 17. Just for explanation purpose, I'm giving 17. And then, and if I want to multiply the third ciphertext, result will be this. This is 34. Okay. See what? We operated on the ciphertext without needing the key. That is what we did it in the previous one. We operate on the ciphertext without any key. We didn't decrypt it. We didn't decrypt it. Without decryption, we work on it. That is the speciality. We are working in the domain, other domain. Okay, so this is the thing. So we did without needing the key, we did it. So, but no matter we compute, the final result is nothing but. So this is the values encrypted 34. Now I am using my private key. If I am using decrypt, this value is stored in decrypted 34. In case if I print the value stored in this one, means that will be 34. So clear? This is simple integer mode of explaining the value of the homomorphic encryption. I think you are comfortable with this one. If you understand this one, then I can take off. All the 3 methods I can establish, and you have to say what is the difference between all the 3 methods. So clear? I introduced what is homomorphic encryption. Okay, so what else you do with the plain text? The same thing, that is same operation. We are doing encryption, that is we are in the previous slide itself I said. So I can say, so that there is nothing but this is the original one and this is the encrypted format. So I'm going to add the encrypted, that is encrypted format alone. I'm doing the operation, but the result is going to be the same. Okay, but the result is going to be the same. Literally I do it, the same thing result. So this is what I'm going to say. Now we get into the 3 modes of homomorphic encryption. So till now what I explained to you means what is homomorphic encryption, and I gave you an integer example for that one. Okay, so what is homomorphic and what is the main categories means partially homomorphic and that is leveled fully homomorphic and fully homomorphic. So these are the 3 major categories in this particular one. Clear? So what is partial homomorphic? Partial homomorphic means, already I told that. So it supports only one type of operation, either addition or multiplication. Partially homomorphic means either you have to do any one of the operation, adapt one of the operation, either addition or multiplication, not both at a time. Clear? Then I can say it is going to be partially. In leveled one, what I can say, I can support more than one operation, but there is a predetermined, that is, we have to fix it, which operation have to. I can use addition and multiplication, okay, as well as I have to fix this number of time, I have to multiply. I cannot do more than that. For example, I can do addition like anything, but multiplication can be done for only 50 times. This is nothing but predetermined size. I'm going to fix it. Okay, if I fix it like that, then it is going comes under leveled one. So here I can do both multiplication as well as addition, but I'm going to fix the multiplication as it is going to be fixed time only we have to do it. Then we can go for the leveled fully homomorphic. So what is next one? The final one is nothing but fully homomorphic. It's arbitrary computation. I don't fix anything. I don't fix anything. So either it may go on 500 or 5,000, whatever maybe, it can go for any number of times. I don't fix any number. It can run for any number of things. So if you don't fix the operation, that is plus operation, minus operation, I make it free. Okay, there is no bound at all. It can run for any number of times. It can do any number of arithmetic operation. Then it is called fully homomorphic. The most strongest one is nothing but FHE only. The most strongest. The reason is you can do as you like. You don't fix that one. You have to do this one. You have to do like that. I'm not fixing anything. Okay. So the first one, there are three systems I'm going to introduce. The first one is nothing but Pioneer system. So this is for partially homomorphic encryption. For each encryption method, I'm going to introduce one familiar one. Okay, Pioneer encryption method is based upon the partially homomorphic encryption. Okay, so in here, what we can do in Pioneer encryption means you can use any one of the operation, either add or multiplication. So you can do these two, any one of this operation alone. So I have to go for the particular example. So I choose like RSA method. You can go, that is RSA also one of the, that is partially homomorphic encryption. RSA, that is Elgamal and Pioneer are the three partial homomorphic encryption methods. I choose Pioneer since RSA may be familiar to you, Elgamal may be familiar to you, Pioneer is not known to you, so that I choose this particular Pioneer crypto system and it comes under partial homomorphic. So we are going to do the thing. So just like it should be a large prime just for numerical, that is slide purpose. I take a small numbers to expand, that is the thing. So what is the climax? You must remember the climax. So this is the climax. I want to ask you several times, what is the climax? Okay. So you take with these elements 2, or what happened with it is 15 something else, or what else? So 3. Okay. So you can take M1 equal to, I forget about the number, what is the thing, and M1 equal to this one, M2 equal to this one, and M3 is nothing but this one. And what I do, 2 plus 15 equal to 17. And if 17 is multiplied by 3, I will get 51. Okay. So whatever may be the thing, that is, if I go for this one, that is 2 plus 5 equal to 17. E of 2 plus E of 15 is also equal to what I have to prove? It is 17. This I want to prove. Then only it is going to be homomorphic. This is the ultimate climax. Okay. So now you come to nothing. I just take two numbers. It should be large prime only, like RSA, P and Q. Then I have to go for the same thing, that is multiplied by the thing. And then I'm going to choose the parameter lambda, and I choose this value G, and I go for computing the value mu. So these are all the values. I put a particular value, and these two are declared as public key, and these two are declared as private key. Clear? Next. Just after key generation, I am going for encrypting the value M1. What is the actual data? So what is the actual data here? The actual data M1 equal to 2. Okay. Look at that is, I choose the corresponding value. I go by the pi layer method. I got this result. What is the encrypted value of E of M1 or E of 2 equal to 1203? Is it clear? E of 2 is nothing but 1203. I get this value. The next value is nothing but M2 is nothing but 3. So E of 3 is nothing but what I will get? 819. Okay, I go for a particular value and I found all those things. Okay, I go for this one, I found this value. Okay, then what is your question? E of 2 plus 3 is nothing but E of 2 plus E of 3. This is nothing but that is homomorphic. Okay, or that is this result will lead to this result also the same. Or I can say that E of 5, what is E of 5 will be the same of E of 2 plus E of whatever may be the thing. Okay, I have to prove that E of 2 plus E of 3. Both are going to be same. These two are same. So here I stop with 1203 and the next one is nothing but 819. So I have to go for that is homomorphic. What I have to do? I have to verify M1 plus M2 equal to 5. Is it clear now? M1 plus M2 equal to 5. Then if I do this one, the same operation I am getting now. This is the value that I go by the pi layer method. So I have to go for C3 is nothing but C1.C1. That is the hypertext and I'm going to get it. And I'm using the L function and get back the same value 5. This is the climax. Is it clear? You can suspect that how you are saying. So the pi layer proved that it took two values. Look at the previous slide. So this is one value M1 equal to 2, M2 equal to 3. And the corresponding hypertext is these two are things. Then he go for that is computing C3 is nothing but we are doing the thing addition in terms of that thing. So we are getting this is the hypertext one. If I that is decrypt that is 357, I will get back 5. That's it. Is there any doubt? Is it clear? This is the thing. That is in the previous one I say I get some that is my own key. Here you may not, that is the thing. Here I get this one. You may not accept this point. This is a very generic example. I just have 5, 12, 2, and then I does the thing. And I'm saying that the result will be the same. You may not believe that one. But pi layer proved that you can take the same M2 and M3, M1 equal to 1, 2, and M2 equal to 3. I'm able to get this value. M1 equal to 2 and M2 equal to 3. If I add literally, it will be 5. And if I decrypt the value, I'm able to get 5. Clear? First method. Okay. So the next one is nothing but, so this is the very familiar method. So this is the abbreviation, that is second model. This is the second category of homomorphic encryption. Here I can say it is nothing but leveled fully homomorphic. What is the advantage of leveled fully homomorphic? We can go for two operations at a time. And one thing is, what is the constraint in this one? We can use any one of the operation or particular operation for fixed number of times. That is the constraint. Rest of them, okay, so the next one. So for this method, so these three are the BGV is nothing but the name of the persons, Gentry, Vaikundanathan. So these two are going to be the very familiar persons in the crypto systems. Okay, in the applied cryptography, they are the pioneers. Okay, Gentry and Vaikundanathan, they come out with that is leveled fully homomorphic function. That is their name, first name will be written and it is abbreviated like this. So they can support homomorphic addition and multiplication of encrypted data. And then we go for this one. So here what we can say. So here we say that is some of the method they are going to use it. Therefore, I'm going to restrict the thing. So likewise, the previous pi layer method, here also I go for the key generation. So look at the key generation and the secret key. So I choose simple value to calculate this one. Okay, so if I choose a bigger value, it will come like this, anything. Okay, then I go for the public key. Okay, now what I'm going to encrypt? What I'm going to encrypt? What is the value? X is equal to 2. So this is the value I am going to encrypt. If I encrypt, okay, so first I have to convert it as a polynomial that I don't want to go for the entire explanation of the thing. Then if I encrypt this one, that is then what I will get, that is compute the cyber that is components C0 equal to 8 and C1 equal to 14. So this is braces is missing. So the output of this one is nothing but 8, 14. If I encrypt 2, I have C0 one value and C1 other value. Okay, if I talk about that one, and that takes a lot of time, so that I just for simplicity I will skip it, and in the topic I will come, that is hard security part, I will come to the thing how we get this one. This is nothing but that is learning with the that is learning with the errors. This is the format, learning with the errors. Okay, so using this learning with the error model, I'm getting this values, I'm substituting a simple value so that I come out with this one. Okay, so if I decrypt it, what is the value? What is the value I encrypted? X. That is comes out to 8, 14. If I decrypt 8, 14, what I have to get? 2. The same thing. So it may look like simple for you, but I put lot of effort to come out with these values. Okay, I'm get back the value 2. Clear? C0 and C1 I does something. That is, what about the value? C0 value is 8 and C1 is value 14. I'm not lying anything. Is it clear? You can verify it. C8, 14. That is, the thing is, I'm able to get the value. Okay, and that is correctly recovered. Now, likewise, X is equal to 3. I'm going to, that is, encrypt one more message. Similarly, if I does like this, C01, C0 prime and C1 prime is going to be 11 and 19. For X is equal to 2, I got two values, 8 and 14. If I encrypt X is equal to 3, I will get two values that are nothing but 11 and 19 by the same procedure. I don't want to repeat the procedure. I just, for simplicity, I skip it and rightly direct value. If I decrypt 11 and 19, what I will get? 3. If I decrypt 11 and 19, I will get 3. Now, as per that is homomorphic encryption, what I have to do? I have to add the ciphertext. I have to add the ciphertext C0 plus C0 prime, C1 plus C1 prime. That is, bracket is missing. That is 8 plus 11. Are you able to remember? Here I will get 8 and 14, I think so. And here 8 plus 11. Are you able to get it? And then that is 14 plus 19. That is, the result of this one is nothing but 19, 33. If I decrypt this value, what should I get? If I decrypt this value, what should I get? If I decrypt this value, what do you get? 8, 40. 2 is encrypted. This is the encrypted value. If I decrypt it, I will get back 2. Get back 2. So this is the value. If I encrypt it, this is the value 11, 19. Okay. So if I decrypt it, I will get back 3. Now I go for adding the ciphertext 19, 13. If I decrypt it, what I will get? 5. Okay. That's why that is 5 mod 5. That is 5 mod 5. I'm getting 5. Here I'm getting 5. Clear? I'm getting 5 here. Therefore, it becomes 0. Otherwise, it won't become 0. For 5 mod 5, from the beginning, I'm using this, that is this quadrant, and this is the same thing I'm using. So clear? So both are same. The climax, are you able to understand the climax now? Failure also used it, and BGV. And that is failure based on that is, I will say, the hardness, and BGV use some other method, a different method, a recent method, very recent method. They come out with the leveled fully homomorphic encryption method. There also they proved that they are able to prove that they can take any two message at a time and then encrypt it. And if you add the ciphertext, I'm going to get back. Here what I'm doing homomorphic addition only, and I'm going to do modular multiplication n number. It is limited number of times only I can do. So if I want to do the thing, so this is nothing but limited number of times. There is no scope of doing this modular upload. For example, if I want to find 367 mod 5 means how many times I'm going to divide? That's it. Okay, I'm going to go for fixed number of modulo addition. Okay, that's why we comes under leveled fully homomorphic. You can do addition n number of times, but modular exponentiation I can do limited number of times. Therefore, it comes like this. Clear? Second proof. Okay. What is the next method? Fully homomorphic. The third method is nothing but fully homomorphic. So fully homomorphic function, here there is no restriction at all. There is no restriction. Here I am going to introduce CKKS, means Cheon, Kim, Kim, Song. So all are going to be the author of that particular method. So it is abbreviated as CKKS. It's a fully homomorphic method. And the method, that is advantage is nothing but, so they can work on arithmetic, on real or complex. In the previous one, I worked on the integers alone. In the first piler method, as well as in the BGV method, I work on only integers alone. I took integers. Here you can take any real number or complex number also. That is the first advantage. Are you able to understand the difference? The first advantage of this one means I can work on a real or complex number, and that is what is the advantage of this one is nothing but we are going to. So why we are going to use this real or complex number means it can be adaptable for machine learning as well as for data analytics and signal processing. So we can apply this particular homomorphic encryption in different applications. Okay, different applications I'm going to give it. So what is the vector I'm going to take? Means 1.2, 3.4. I will understand the reason why I took 1.2 this time, whereas the previous time I took 2, 3 like that. So this time I take 1.2, a real number. Likewise, you can take a complex number also. Okay, so it is difficult to type in LaTeX these things. That's why I'm not giving an example for complex number. I just stick on to the real number example. I took that is V1 equal to 2 vectors, V1 equal to and V2 equal to. If I add these two numbers, what will happen? 1.2 plus 5.6. What is the answer? 6.8. Okay, 3.4 plus 7.8. What is the answer? 11.2. This is the expected answer. If I go for addition, homomorphic addition, what is the final result I want to get? This is the result I want to get it. Literally, if I add these two numbers, I'm getting this result. So what is the final result, final outcome? This is the final outcome. Is it clear? So how I am going to do it with the help of CKKS? Okay, so for that, I'm going to use some scaling factor. This number, real number, can be raised up to scaling factor 2 power 10 and will be converted into integer format. I'm not going to work on the real number format. I just converted into that is integer format so that I go for scaling the thing. Is it clear? Uniformly, I'm scaling the thing. Is there any doubt? Is it clear now? Are you able to follow the thing? So, and that is each vector should be converted into, and that is the background. I don't want to go much detail into this one. This is a post-quantum crypto system, post-quantum method. We are using, in specific, we are using RLW method. I will come to you later. And this is the process. Here, I'm going to convert the vector into a polynomial, and V2 can be converted into a polynomial. Then using here itself, I mentioned using RLW, encrypt this one and convert, that is compute the vectors, that is hypertext this one. Okay, and this is the bubble key and this is the model. Okay, this is the RLW working process. Okay, then I skip this part. Okay, this is the undergoing process. It has to underwent this one, and I'm getting this value. Okay, so for example, that is I do go for the encryption, and finally I'm going for the decryption. I'm going to add these two. These two are the values. C0. This is the structure. I'm going to use C01, C0 plus 2, C11 plus C02. That's just I'm adding the values and adding this value. This is the decrypted value. And what I am dividing this one? What I am doing here in the last step? What I am doing here in this step? Rescaling. I am doing the rescaling. First I scaled it, scaled the value. I am rescaling. If I rescaled it, what I get? The same answer. The same answer, na? Okay, I skip for your understanding purpose. That is, then it becomes teaching the RLW, that is post-quantum cryptography. That's why I skipped it. I just take the numerical example and I explained it. So the ultimate aim is satisfied in all the three methods. Okay, so here I took these two vectors, V1 and V2, and the same, what else may be the normal operation. If I add it, the same answer, I'm able to get back it, the same one. I just intermediate results, I skip it. The reason is I have to explain a lot and I have to do a lot of calculations in that, so that I just skip it and I see shown the particular result. So on all the three methods, what do you infer? In all the three methods, what else may be the input? M1 and M1. This is the ultimate thing we are doing. Na? So M1, you take something. M1 is nothing but 2. M3 is nothing. M2 is nothing but 3. Then E of M1 plus M2 equal to E of M1 plus E of M2. So clear? So this alone we are going to prove in all the three methods, so that we can say it is going to be homomorphic encryption. So all the three methods, I took three different examples and I proved this one. Is it clear? Shall I move on? So I said, what is the meaning of homomorphic encryption? Why they named this encryption as homomorphic encryption? Okay, if you work on the plain text, what result you get? The same result will if you work on the ciphertext also. So the answer does not differ if you work on the plain text as well as if you work on the ciphertext, the answer differ. Therefore, we named as that is homomorphic encryption and the variants of homomorphic encryption. And for each variance, I introduce one particular method. For partial, I introduce Pioneer, and for leveled one, I introduce BGV, and for fully homomorphic function, I introduce that is CKKS. So three methods have been introduced. Okay, so now we go to study about the security standards. Okay, so what is the security standard? So here I mentioned here, failure is based upon the DCR assumption. Okay, and what is the homomorphism we are going to go for? Additive only, and this is what is that is security level in the CPA. So that I am going to explain it. So what is DCR assumption? This is the DCR assumption, decisional composite residue assumption. So this is nothing but this is based upon the how we can say integer, that is RSA, that is integer factorization. Likewise, we go for this one. I need to find Z such a way that congruent to y power n mod n squared. If I am able to, if this is the hard problem, this is integer related problem. Okay, it is an integer problem. It is an integer modulo problem. Therefore, the number theoretic, therefore, it is a number theoretic hardness assumption. And I took the Pioneer system, and it is not, it is strength is based upon the number theoretic method. So this is the strength of this particular problem. And the next one is nothing but RLW. That alone I am saying that learning with the errors. Learning with the errors means you have to learn, the error will be there, the residue will be there. With that, how you are going to understand it. That is nothing but learning with the errors. And then ring means I am taking this ring, that is, this is the ring structure, I am going to use it. The elements I have to take it from the ring structure. And what is the difficulty in this problem is A is going to be one vector and B is going to be another one. And then if I want to differentiate this one, if I find the S secret, that is strength of this one. And this is nothing but a ring with a learning with the error problem. This is the recent one. And the next one is nothing but MLW. So based on this one only, the post-quantum system will construct it. Okay, so the other parameter which I mentioned here is nothing but all are going to be indistinguishable ciphertext, that is CPM. So all three schemes will be proved under this particular method. So what is indistinguishable CPM means? So here, so how can I simply, it is a game-based method. I want to prove that this encryption method is going to be strong. Okay, so how can I understand means? I can give an example, then you can, that is, instead of teaching all these things, I can give a simple example. So E of 2 equal to 3, E of 3 equal to 4. Then this is one encryption. E of 5 equal to 6. E of 6 is equal to, or E of 16 equal to 17. Third one, if I write E of 110 equal to 111, E of 1001 equal to 1002. So what else? I took three texts. Okay. So 2 and 3 are first images. These are all the outputs, 3 and 4. And 5 and 16, 6 and 17 are the ciphertext. 110 and 111 are able to predict what I am doing in the encryption. Easily you can predict. Just whatever may be the input, just you add it. Okay, just add it. I'm able to easily guess it. Okay, so now from all the three methods, we provide some encrypted value. You cannot predict what is the encrypted value. If you are not able to predict, then only it is the success of the encryption method. I'm going to say that if I am giving the plain text. Okay, so if I am giving the plain text, you cannot guess what can be the output. That is what can be the ciphertext. You cannot find it. So if you are not able to find it, or 50% alone you are able to, sometime you may guess it, sometime you may not guess it, means then I can say that my encryption method is going to be strong. That is nothing but INCPA, indistinguishable chosen plain text attack. You can take the plain text. From the plain text, you say that 2 and 3 are the plain text and what can be the output, that you are going to guess it. Okay, so this is the key. You generate the key. This is nothing but choose and place net queries. That is, you have to give, that is M0 and M1. These two are the messages you are giving to the challenger. And then that is, you are going to guess it. That is the ultimate aim. What is INCPA? I explained with the help of this example. If you are able to guess it less than 50% means I can say that encryption method is going to be strong. Okay. Then the other one is nothing but INCCA. That is nothing but choose and ciphertext attacks. Okay. So if you choose two cipher, what is can be the plain text? That is the reverse way that I do. Okay. So this is the security standard, and what is the cloud security features? And already I mentioned that encryption alone will support you the confidentiality as well as data integrity. Okay. Other than that, what we can do here? So what are the things we can say? That is confidentiality. So here also the confidentiality retains. Why? That is, we are going to, that is, we can do, for example, if this is the element, I can encrypt it and I can send, that is, store it in the cloud. You can process with the encrypted data also. That is the advantage. For example, this is my password. For example, that is username and password. This I can encrypt and store it in the cloud. What else I want to do? I can do what else, this operation and the encrypted one, the ciphertext. If I do the operation on the ciphertext, that also going to be same. So I don't want to decrypt it and do it again. If I decrypt it, someone else leak their data, can see the data. So that in the encrypted form itself, I can do the operation. So that confidentiality retains. So that is the advantage of the cloud. That is the HE method. That is homomorphic encryption provides confidentiality also, the first property of the security system. Okay, either it may be a financial record or healthcare, whatever may be the thing, I'm going to store in the third party in the encrypted fashion, so that they are going to operate on the encrypted data only, not on the plain data. So that it is going to be, the thing is, I'm going to say that the Siri is how it is going to fetch the data. And then second one is nothing but secure data processing. We are going to perform the computation on encrypted data without decryption. That is the second advantage. And third advantage is data integrity. We cannot tamper the data, that is default. And we are able to follow the regulatory compliances. Example, HIPAA and GDPR, we are going to follow it. And zero trust, we can store anywhere. Okay, we don't want to believe on the thing. So we can zero. The reason is it is in the encrypted form. So I can store it anywhere. So zero trust party. So operate in untrusted without relying on the third party integrity. I don't want to bother about them. Okay. And that is privacy collaboration. For example, you can collaborate on the external parties on the sensitive data. Okay, so we can go for privacy preserving collaboration. We can go for any that is partners or researchers. We can go for it. Okay, since we are not going to anything with its own. We are going to go do with the encrypted data set only, not with the raw data set. So that we don't want to go for anything. So the originality cannot be touched by thing. It cannot be tampered. So that we can go for the fraud detection. For example, if you go for this fraud detection means in a particular bank, your client has made some financial fraud, means all the transaction will be sent to the other bank also. In case if he does some financial fraud, that is mistake means, so without exposing the particular name of the customer, they can identify the thing. So that alone, that is, they are not sending the original data, they are sending the encrypted data. So it will be very good. It is a separate entity, a separate research is going on. So how to identify the financial fraud detection using this HE method, and that is secure outsourcing. So the thing is cloud without losing any control, we are going to do it. And life cycle security. So from the creation to deletion, it is in the cloud. We don't bother about the thing. So it will be safe. It is in the safe hands. So these much things which will be supported by the cloud. by the, that is in homomorphic encryption. These are all the, that is security, cloud security features. These are all addressed by the thing. So we can do the thing that is with this 8 point alone. I'm able to identify it. So what it says. Okay. Now we go for the particular, that is the thing is, and I can say for pi-layer crypto system, that is for pi-layer homomorphic encryption. So usually they will give, I'm not giving an example for that one, then later I will give. So I'm going for this one, first application. I'm going to give 3 applications based on homomorphic. Okay, so the first one is nothing but Happy Kids. I'm not that is naming this one. It is a research paper. Okay, Happy Kids, they provide, the thing is privacy preserving phone usage tracking. The thing is, we are using smartphones. Okay, so our children also using smartphones. It can be used for educational purpose as well as for entertainment purpose, or that is something it may be abused. Okay, so to prevent that one, what we can say, so we have the mechanism. So there either remote monitoring or remote locking. If I want to control my children in using the mobile phones, I can go for, that is remote monitoring or remote locking. So these 2 things. Okay, in child lock, you can, in TV, you can say child lock, we can put in. Likewise, we can go for remote monitoring and remote locking. So many Google, that is applications are there in the Google Play Store. I can download it and I can store, that is the thing. What wrong in it? So I am using, that is as a parent, I am using a particular app that I downloaded from the Google Play Store, and if I use it, means that is my child may not able to freely access any particular content. Then I am giving the ratings for that app, that is 4.8, but my child will give 2.0. So you are downloading the app based upon the ratings alone, na? Is it clear? I can use any one of the app, either remote monitoring app or remote locking app. If I use as a parent, if I use it, but the other also, they also can give the review, that is give a review about the particular app. He will give a negative, that is negative opinion, or negative, that is very less rating for that particular app. So the app should depends upon the ratings. So how can I balance both the thing? Okay, so I don't want to allow them to see all the thing, but at the same time, I want to prevent it. How can I do this one? Okay, so that is, we can do this. This is the example scenario. This is the scenario they taken it. Is it clear? Is it clear? The application is clear. Then that is, it will help us to, that is, the well-being of the child's character may not be spoiled by the abuse content like that. So I want to being a well-being of the particular one. So it creates, that is how I am going to do it. Means not only with this one, this is the structure I am going to create. I'm not creating. The researcher created this Happy Kids app, created like this. They created the, that is they collect the usage data from child's phone.
Yeah.
One. I think. Okay. So first one, so that is the child is using the mobile. From his mobile, I'm going to collect the data. So that data is not the original form that I can collect it in the encrypted form. There I'm going to use the HE. Is it clear? And where HE comes into, it is the practical utilization. So I'm going to collect our data from the file phone that I'm going to. Next one, server uses machine learning method. You can use any machine learning method that is trained by who are all the, that is members in that particular ML model, means parents, child psychologists, and social scientists. They will find a well-being score. Okay, there is an ML method, and first we start with, that is from the mobile, the data is going to the server, not the plain data is going there. That is there we insert our HE mechanism. So using HE mechanism, all data will be encrypted and stored in the server. The server manipulates what server utilizes. The server utilizes a machine learning algorithm. The machine learning algorithm does not use the raw data; it uses the encrypted data. Understand the effectiveness use of the particular homomorphic encryption now. That the machine learning algorithm train this, it is made up of these people, and it will predict something, that is, it will give you a score called well-being score based upon the ML. The parent receive the periodic update on the, that is, the parent will receive the well-being score. In case if there is, the score is less, then he can intervene. That's the thing. In the proportional inclusion, this child, that is, this is the entire setup. Okay, it's a nice setup. That is Happy Kids application. Where they are including homomorphic encryption, and they are including machine learning algorithm, as well as all persons are involved. If the well-being score is less, then the parent can be cautioned. He can control the thing. So both the child privacy may not be affected, and the server cannot know about the thing. So it is working on the raw data. So it won't work on, that is either thing. So the thing is, the privacy of the child collected data is encrypted in the HE, and is it clear now? That's the thing I made it. This is the way it has been set. So this is the ML model. This is the secret key score, and this is the way. So here that is the thing is, I said already, that is the ML will identify the well-being score from the encrypted score only. So this is the outlet, and it involves three points: the parent, the child, and the server. The parent has three, that is, create the secret key and evaluation key, not a public key. And that is how the data will, from the phone, the child, that is from the child phone, the data will be encrypted using, that is, HE method, and it will send to the server. This guarantee the server cannot access the child data. The ML model uses the evaluation key to, that is work on the, that is, encrypted data, and then result will be, that is, will be decrypted and sent to the child. And that is, here we are using CKKS. Okay, so for homomorphic encryption, I don't bother about the ML method. Here I don't mention which ML method is used to identify the well-being score. Here I am concerned about the homomorphic encryption, how our method will be used in the practical scenario. So for that, I'm just, this is the outline, and this is the, that is architecture, they made it. This is the architecture, they made it for a privacy model. They are involving, that is ML model, and that is your FDP, that is one means secure cloud, as well as AA, and then my topic is HE. I involve both the thing, all the things. Okay, using cloud, we are storing. Using ML method, you want to identify the well-being score. Using HE method, I'm going to encrypt the data. So all will place together. Okay, so this is first example. Okay, so clear? So how HE is used in practical scenario. Okay, next one, that is, for example, if any elders are residing in your home, so whether, so for example, if they cross 70s or 80s, whether they sleep normally, they have to take that is a sleeping tablet, otherwise they won't get the thing. But if you go with the prescription to the medical center, they won't provide you the their sleeping tablet as they like. Okay, in case if they provide the sleeping pills to them as they require, means it can end up, that is, they can, anyone can take so much of pills of that is sleeping pills, it can go wrong. That is one issue. Is it clear? Are you able to understand? Now I am creating a platform for the second scenario. So any, that is, for example, any drug means not, that is a medicine, either it may be narcotic, or it may be a sleeping pill, or it may be a painkiller. So much of painkiller is also not advisable. Okay, so if you have a neural problem, okay, so then I cannot go for so many, that is, painkillers, that it will affect kidney, that is, so many things are there. Okay, so this is the scenario. So based on this scenario, that is privacy preserving prescription drug management using HE. Okay, so here also, that is the thing is, if they go with the prescription, then he can buy in, that is, for example, he can consult. They may do it cleverly, they mention it. I will, that is, in case I have a sleep issue, I consult one doctor, he give one prescription. There also one, that is sleeping pill is there. Then I consult second doctor. He also give the same, that is some sort of, some second, third doctor. I have 3 prescription in my hand. Okay, so 3 legal prescription in my hand. With this 3 prescription, I can buy 3 times. For example, 30 tablets is allowed, means I can buy 90 tablets. I can buy 90 tablets. This may not cost, but it becomes an addiction. It becomes an addiction. Therefore, I can go for, therefore, they are saying that 46 people die every day for overdoses involving the prescription opioids. So I'm not saying that is the paper, that is the second application paper, they gave the statistics because of the overdrug, this much people are dying every day, not okay. So that they go for the prescription drug management program. So for that, they are using machine learning method. The machine learning method is called PPML and FHE, our FHE. Okay. So to preserve the benefits of PDP, that is drug management program. So the thing is how here I am going to see the thing. So how the transaction between the patient and the server and the doctor and the pharmacist. Okay. The previous one, child, parent and the server. Here the patient, server and doctor and pharmacist, how the action will be takes place. So here also we are using a machine learning method, and here also we are using our fully homomorphic encryption. The thing is here the prescription will be encrypted form. It will be stored in the encrypted form. That's it. Okay, so the prescription made by the doctor will be stored in the that is encrypted form. The pharmacist will inquire the encrypted data only, not the translated one. From the encrypted data, so for example, for this month, how many times he purchased the particular pills, that I can come to know it. So by looking at that particular information, I can control him. I cannot allow the particular patient to buy further pills on the same month. So that scenario, that alone I'm explaining everything. So how the description will be there. And here I'm using BGV method. What is BGV method? You know the second method, that is leveled fully homomorphic. Whereas in the previous method, what I used? CKKS I used. Okay, FHE I used CKS. Here in both the thing, I purposefully not mentioning which machine learning method I'm using. But I'm using a machine learning method, not I am. That is the researchers using the machine learning method to identify all those things. Okay. So the third one is, this is second application. And the third application is going to be very sensitive. Okay, so the thing is enabling secure detection of suicidal ideation. So those who have the suicidal thoughts, the suicidal inclination, they also can be prevented with the help of our homomorphic encryption. So three different example, three practical example. So we can slow down or we can reduce their thoughts. Okay. So for example, if any person have the suicidal thoughts, his conversation may not be normal. I wrote everything. So what is the thing? It is if a person want to think about or planning about suicide means, so it's a major concern. How much percentage it was increased from 19 to 2017 means 13%, 33% it has been increased. So we want to detect those person having the suicidal thoughts. Okay. So for that is he introduced a machine learning method to identify the suicidal detection. So again, we use the machine learning method. Third application, we are using machine learning method to identify the thing. Here, the persons subject means the patient. Patient's natural phone conversation with the suicidal ideation, lower emotional variability with the health controls. So they are using this method, that is machine learning method, as well as their emotions. So this is the setup. For that, they are using this one, that is Priori is nothing but a smartphone app, can detect this suicidal ideation from the natural phone call speech data. They are using CNN, convolution neural network, as well as DNN. What is DNN? Dense neural network. Dense. Okay, here not we are going for deep neural, that is dense here. So that I said that is CNN as well as DNN, and this is the data set they use it. So EMAS. So what the data set consists of the futures is nothing but emotion, mood, and other suicidal thoughts they have. So they have 400 hours of conversation that is recorded by the 43 different participants. This is the data set they are having. Okay, so there is an app. Priori is nothing but a smartphone app. So they are using these two layers. I don't want to get into it. Okay, so this is the data set and what the data set consists of. Okay, so for the security perspective, we have to, for example, you can speak about if you have a person a suicidal thoughts. Okay, so in the that is a person can help him to avoid the suicidal attempt. Okay, in case if it is leaked outside, then what do you say? Think about the person. If this information is leaked outside, there may be a discrimination. Okay, so the societal discrimination is there. So that data is going to be preserved. What else I talk with the counselor? If I, in case if I talk with the counselor, okay, so he can so he can successfully avoid it. In case if the data is leaked, it will be a problem for us. Okay, the second thing, so the prediction may be, the prediction is also, for example, if a particular patient X has a suicidal thought, that prediction I predicted with the help of a machine learning, and that uses CNN as well as DNN method to predict it. If this prediction also preserved, if it is leaked, that is also a problem to the person. The privacy of the person get disturbed. So that the conversation as well as the findings, both are going to be preserved. So for that, we are going to come out with so preserve the data. So the conversation will be converted. It is how that is. It is a good method. That is, you can look at this one. So this is nothing but the Seal. Microsoft Seal is nothing but the HE infrastructure library. A default library you can use. That is nothing but Seal. Microsoft Seal. This is also an architecture. I didn't make it. The third author make this architecture. Look at this one. This is the dialogue between the person to that is counselor, and this is the remedy they can make, and then come to the thing. So everywhere they are, that is Seal means they are going to that is encrypted with the help of the HE. Yeah, wherever you see, that is, look at this one. The cloud will be, that is, all the values will be. This is the cloud. Okay, so look at this one. So here I'm using the HE based data encryption model evaluation using this Microsoft Seal library. Clear? So the conversation as well as the findings will be encrypted form. The findings also in the encrypted form. For example, yes, he has suicidal thoughts more than 90%. If this is the finding, that is also in the encrypted form. That is also in the encrypted form. So the conversation also, for that, what we can say, that means, so okay, so first this method is based on BGV method. Okay, likewise, that is the case, like that is previous also BGV. This method is also BGV. The speech features are encrypted on user's device using HE. Okay, so we are not studying anything unnecessarily. So there is a practical utility is there. So this is the few features can be encrypted, and then we are using CNN. That is, encrypted features will be sent to the CNN for that is studying purpose, for training purpose. Whether these features will lead the particular person's talk will lead to the suicidal inclination or not, that we are going to do it, and then we are going to predict. Encrypted predictions are returned to the user device and the final analysis. So here we are using the FHE machine learning, and then the method, that is the architecture, we are using the cloud architecture we are using. Good. So these three are the applications. Shall I stop here? If I take more, then you have the suicidal inclination.
For participants, you can ask doubts now. So,
Good afternoon, sir. I have one more doubt. So when we are using HE method for some very long data sets,
the complex, it is the time that we have to compromise. That we have to compromise. Whenever you go for security, then nothing will be available freely. It is some layer you put it,
Yes, sir.
it will slow down. It will slow down.
Because apart from time complexity, we need more computational power and also storage space to run.
Computation, no computation power. That is the thing is we are working with the encrypted data. We are not decrypting.
Yes, sir.
It's just encrypted. That is the encrypted data as it is. We are working. Yeah, that is the thing is I won't accept on the computational one. That is the thing is we do some extra work to encrypt everything. There is a possibilities of the thing.
Then
It
what?
will slow down. It will slow.
Then what about the storage constraints in it, sir?
Storage concentration depends upon that. The thing is in app itself. All I said is going to be app alone.
Sir.
It's Happy Kids is an app.
Yes, sir.
Priori is an app.
Drug management is an app itself. They are able to do it. It's an app management only. All the three are going to be app alone, simple app alone. They are able to do it. That is, I mention it. What is mentioned in the paper? That is in the book itself. They mention which type of homomorphic encryption they do use it. Because of that one, how much speed will be reduced? That also they mention it. Yeah, there is a compromise.
So then, what is the difference between this HE and traditional way of encryption, sir? Because if you are using HE, means you're
The
saying
thing is, that is the first topic. That is the thing is, this encryption, normal encryption will support two things alone: confidentiality as well as integrity. For example, if you change the values, for example, okay, so these two are the things. So all other things we can say, that is in homomorphic encryption, the plain advantage is we can work on the encrypted data itself. So in plain encryption, you have to decrypt and then work it. Whereas in homomorphic encryption, I can directly work it. That is the major work on, and that solves all the, that is, I mentioned about 8 different properties. It satisfies the.
Sir, over to the online participants. If you have any doubts, please unmute yourself or chat. Come in the chat. Oh, no doubts, sir. We sincerely thank Dr. A. Balu for delivering such an engaging and informative session on homomorphic encryption in the cloud. The clarity with which you explained complex cryptographic concepts and highlighted their importance in today's cloud security landscape was truly commendable. Your session has provided us with a deeper appreciation of this critical research area and inspired new perspectives among all participants. We are grateful for your time and efforts, sir. Thank you once again being part of our FTP. Thank you. And towards the participants, we'll be resuming our afternoon session at sharp 2 p.m. itself. Thank you. Security is not a product, but a process. Very warm welcome to everyone as we move on to the next session of our FTP. It's my pleasure to introduce Ms. Mahima Mary Matthews, Assistant Professor at IIIT Kottayam. She has completed her MTech in 2016 with specialization in data security from CUSAT University, where she earned the university first rank and holds a BTech in computer science and engineering. She has valuable industry experience, having worked as a SAP techno-functional expert at Accenture for 3 years, along with 5 years of academic experience at renowned institutions like St. Teresa's and CUSAT. Her areas of interest include cryptography and quantum technologies. Today, Ms. Mahima will be taking us through the important topic of packet analysis using Wireshark, a powerful tool for network analysis and troubleshooting. Let's all welcome Ms. Mahima Mary Matthews and look forward to an insightful and hands-on session. Over to you, ma'am.
Good evening, all. I believe let me just stop share for some time. There is a lot of stuff that's opened. So you would have received a link on your Zoom. Are the participants in this room joined to that link? Are you guys in? No. Can you also join to that link, please? It will be helpful for you to see the screen as well. Okay. So please join the link. And you guys don't need edit access to that link. You could be accessing it already, na? Anyone with the link? Yeah, you should be able to view it.
Denied, ma'am.
No, just refresh. You should be able to. WhatsApp curriculum. Okay, I think participants over here, you would have received the link. So that's basically few exercises and a little bit of descriptions about Wireshark, T-Shark, and TCP dump. Okay, so we'll start. Wireshark is very common tool, right? So today's session, I think it will be very simple for you as well. But what we are trying to focus on is how to utilize Wireshark, not just in capturing, but also for forensic purposes. Like if you want to analyze what's going on. See, when I say forensic purposes, it could be also evaluating your network, not just as an after effect of a crime investigation. Okay. So if you want to understand what's going on in your network, sometimes if you are a network configurer, you might have to utilize Wireshark kind of tools to analyze what's going on. Okay. So now, first, what we are trying to understand is what Wireshark is and where it exactly fits in. So I have given you already a description there. Wireshark is basically a tool which can help you in capturing packets as well as analyzing them, right? Now, there is a terminology called monitoring, right? Monitoring packets. Does Wireshark helps you in monitoring the packets? We can do it, but we cannot take any action based on that. So if you want to have packet analysis and some action associated, then which tools do you go for? No. That's where you have tools like firewalls, IDPS, and all those stuffs, right? Again, you are analyzing the network communication and you have to take actions uh, on the live packets. That's what I'm trying to talk. Like when the communication is happening, you want to take some action, right? So that is where you make use of tools like firewalls or like firewall technology and IDPS, intrusion detection, prevention. So what I'm trying to say is Wireshark is basically taking a copy of what is going on in the network only. You cannot take any real-time actions. Okay. You can just sit and monitor, right? You can just look at what is going through your network. But if you need to be able to take some action on what is happening, you cannot do that with Wireshark. Okay. So Wireshark completely helps you in analyzing only. Okay, it helps you in analysis, but you cannot take any actions out of it. Okay. Now there is another one more important point. Wireshark is not the tool that we usually use for capturing packets. Okay, Wireshark is a GUI based tool which helps you in analyzing already captured packets. Why do I say that is because if you're capturing the real time packets, you will have so much of information. So we will try to see what's going on in our network itself, like within like maybe 10 minutes, 15 minutes, the amount, the size of the packets that you capture will increase so much. So in that situation, Wireshark is not what you deal with. Can you keep Wireshark's GUI on always for a capturing purpose? No. So what we do is we do have other background tools like a few I have given you example already in that document, which is TCP dump, T-Shark, etc., which you actually run in the background to capture packets. Now, when there is an incident, you basically filter down the specific packets you want to analyze, and then you use Wireshark. You're getting my point, right? So Wireshark is basically a GUI based tool that in practical purpose, we basically use it for analyzing already captured packets, not real time. For real time, you most probably use some backend tools, which could be T-Shark, TCP dump, or even like as an incident response, maybe Surekata or such kind of IDPS tools will be collecting certain packets. That's what you might have to analyze. Okay? You're getting the context, no? So let's think of a situation where you are the network administrator of this college. Okay. So let's say we have a, what should I say, a file transfer server or an FTP server over here. Now, today morning, like around 10:30, 11, we noticed that FTP server is not accessible to anyone. Okay. So what will you do? We have to analyze what happened now. Like FTP server has gone down at around 10:30, 11. That's when you got the report that server has gone down. Now, what will you do about it? So that's a case of an incident, right? An incident happened, which is kind of reported around 10:30 a.m. in the morning. Now, as a network administrator, now you, and there will be some dedicated security analyst also. Okay. So what you kind of do is you will see the packets that was captured. So one important thing, you will need pre-captured packets in such a case of an incident. Like if you need to go ahead with packet analysis, you need to have packets already pre-captured, right? So for enabling that, what should you do? You should have already set a capturing capability in your network. So are you getting the intensity that in real world that might not be possible always? You're getting my point, right? So what happens is in an infrastructure, like let's take IIIT Kottayam's example itself. So in even when I was learning initially, I was of the impression that all of these devices takes the log of all the entire packets that is going to the network. But think of the size of information that will be there if we are going to capture all of the packets. That's not possible, right? So most of the situation, what happens is that whenever there is an incident which we would have already set as signatures, okay, signature events will be there. Based on that incident, certain packets might be downloaded and kept, whatever. Okay. Now let's take a hypothetical situation where they had pre-enabled packet capturing. Okay. So that won't be there in the real world, but I'm telling you, like, let's assume that in IIIT Kottayam, they had enabled packet capturing. So now you have the report that 10:30 a.m. is when the incident happened. Okay. Now what will you do? From around 10 o'clock to around 11 or maybe even 9:30. Like based on your experience, you will be able to filter down the time exactly when you should start analyzing. So most probably from 9:30 to 11 or somewhere, you can filter down the packets. So then what you do is you send that packets to maybe network security admin analyst. So they actually sit down and evaluate. Okay. What would have happened, right? So that's how mostly packets are utilized and packets are being sent for analysis, right? Now, there could be another scenario where you don't have pre-captured packets. You are understanding that there is something going on with your network. Then what we do is we try to enable packet capturing and sit down and trace the network, right? So let's say we feel that in our network there is some like parallel movements or lateral movements is happening. Okay, so you suspect that. So what you can do is then you can enable some kind of these capturings in your network, and then you capture those packets and then you can start analyzing with that. So my point is Wireshark mostly in real world usage may not be used for real world packet capturing. They are either used as a mostly used as a post-incident GUI based analysis. Like you might have pre-captured like packets there with you, you want to analyze, or if you know that something suspicious is going on, you want to start with understand what is going on, then you go with Wireshark. Okay. So now let's go into the Wireshark tools. All the parts, like if you would have joined, it is easier, like but otherwise I won't be able to put the entire stuff on the same screen. Hope you're in the link, right? You can see now. So in Wireshark, so there is mainly two kinds of filters. One is capture filter and one is display filter. So it's very important to understand the difference between these two kinds of filters. So from the name, it's clear, na? One is capture and one is display, right? So capture filter enables you to filter down where you want, like which interface you want to capture. Okay. And display filter helps you in filtering it out. It's like a GUI based setup where you have set of packets with you. You want to filter it down, right? So that's where display filter helps you. Now, capture filter, to understand what capture filter can do, you have to understand what is like hard network interfaces, right? So packets are coming into or accessible to this network card or this device through those interfaces, right? Now, if you have enabled monitoring on those device on those interfaces, now what you can do is you can capture or you can like see a copy of all the packets that is coming through like in and out of that interface. So that's what is the different interfaces that you see here. So if you see here under this, I can see so many interfaces. So Wireshark defaultly detects all the interfaces. Like if I would have enabled it, the administrative privileges, it detects all the interfaces that is available. So here you can see I have Wi-Fi, I have adapter for look back traffic capture. Then there is a few local area net connections. Then you have Ethernet, USB, PCAP, one, all those things. So these are the different interfaces that Wireshark has detected for capturing in this device. If we wouldn't have enabled permissions, then maybe it won't detect that. You will have to give it permissions, right? Since I have defaultly given the permissions, that's why it's detecting all these interfaces and showing it out for you. So these are the different interfaces, and you can see I have connected to Wi-Fi. So that's why I have all of my traffic on Wi-Fi. Can I get a LAN card? LAN cable. Yeah. ഇല്ല ഇതിലൊന്നും ഹോട്ട്സ്പോട്ട് ചെയ്തുതരുമോ? അതല്ല, ഇത് ഹോട്ട്സ്പോട്ട് കണക്ട് ചെയ്ത് തരാൻ ഈ ഡിവൈസിൽ. ആ okay. So now you can just look at the different interfaces that you have. Can you please open your Wireshark? Open your Wireshark. Now those online, hope all of you has opened your Wireshark. Can you please confirm? Please leave me a thumbs up. People online, can you please respond? Can somebody respond, please? Am I audible to you guys? Participants? Okay, thank you. So hope all of you have the Wireshark open. Now based on, thank you. Based on whichever network you're connected to. So in this case, you people over here, most probably you will be on LAN and attending from a home, like based on the network that you're connected, you can see traffic over that particular interface. Okay. So what do I mean by interface? Interfaces are basically like you can imagine as a port connections in this device that you're trying to run Wireshark on. Okay. So when you run Wireshark on a specific device, it will detect all the interfaces that is available in that device. Okay. So suppose you need to monitor the entire traffic in this college. Where will you run Wireshark on? Which LAN? LAN where? You should run it on a device, na? Can you monitor the entire network, college network, by running Wireshark on your device on this desktop? Exactly. If you are able to, like the main switch from which it is entirely getting routed, like on the L3, like originating, not terminating, the originating end, if you are able to monitor like every traffic that is going out and in, if you put a packet capture over there, then you are able to analyze this complete network. So understand that it's very important. Wireshark, some people think like if you set up simply Wireshark and sit down, you will be able to monitor the entire traffic. No, you will be able to see the traffic. Maybe you can do something else, like some other malicious activity and redirect the traffic. That's a different story. Okay. What I'm talking about is a normal setup network. Then you will be able to get and see the traffic that comes to your interface that is available on this device. Okay. So choosing the right device to run Wireshark is very critical. Okay. Now, so you can look at the different adapters that is available in your device. You can see the traffic activity going on in Wi-Fi, and I am just double clicking that. So now I am able to see the traffic that's happening on this interface. Okay. So you should be able to, like whoever is in this class, I think you are connected over LAN. You should be seeing something like ETH0, right? Which is your Ethernet interface. So there is where your traffic is happening. So you double click on that, you should be able to see the traffic. People online, based on however medium, like whichever network you are in, like LAN, Wi-Fi or LAN cable, you should be able to see the same. So based on that, just double click on whichever network you see the traffic on, just select that. Okay. So we discussed two major things. One is identifying the right device on which you should be running the Wireshark on to be targeting the packets you are interested in, right? Now selecting the right interface on which you want to again monitor. Okay. So two things. Now, once you have started capturing, it's simple things. See, here you have a stop button. Okay. And here you can refresh, and then you have a magnifier over here. You can like press this to, maybe if you want to see it better, you can do that. Then yeah, we'll get into these things. So let's say I am stopping the capture. Okay. So then you get these other buttons enabled. So if you want to restart, then you should be clicking on this. Then there is the save capture, then close this capture, reload this file, all those kind of things are there. Then go to next packet, previous packet, then go to the first packet. All these kind of things are there for you. Okay. Can you just look into all these things? Just start the packet, stop the packet, capture, and maybe save the packet, capture, and all those things, and see. It's basic stuff, but we are just familiarizing it. I have shared some a Wireshark cheat sheet as well on your Zoom link. I'll share it with. I cannot be opening WhatsApp. Yeah. So I think you guys just familiarize with all the buttons that is there. Now it's important to understand the different kinds of displays that is available for you. So here you have the packets that is being displayed. Then you have, here you have the details on the packet, and you have the byte information. Now I can change this. I can go to edit preferences, and if I go to this layout. Okay. I can actually change my preferences. I can change the first thing to different one. So instead of packet list, if I'm interested in seeing something else, I can change it. And in the second one, so this part is pane 1, this part is pane 2, this part is pane 3. See, it's like a normal tool, right? You can customize it based on the visual, I mean your visual preference. Okay. Now see, I'm changing this packet bytes to packet diagram. Okay. And apply. So this helps you in visualizing packets. So when you are learning network, you would have learned, we would have drawn these packet structures, no? Like with pen and pencil, scale and pencil, we would have drawn these packet structures and studied. So exactly the same way you are able to visualize it here. So what I did, I went to File, Edit, Preferences, and Layout. There, the third one I changed to Packet Diagram. Now I am able to see each of the packets in the packet diagram format. I'm able to visualize my packets. Okay. Now I right click on this, and if I do show field values, it will populate the entire packet exactly like that for me. This is very important when you are starting to learn packet analysis, because when you see the packet structure in your mind, this figure should come. Okay, like which exact field should I be looking for? All those details, if you want to understand, you should be familiar with all of the different protocols and their packet structures. So here you can see TCP has a certain structure. UDP has a different structure. Then let me look for another protocol. There should be TLS. See, TLS version 1.2. It has a completely different structure. Then there should be ARP. No, it's on my Wi-Fi. Yeah, so just explore the different protocols and their packet structure. Just look at the packet structure for different protocols. So where do I see the protocol? I have a field called protocol here. So you would have already known that each protocol has its own frame formats, right? Now that's what we are visualizing, looking at the different protocols and seeing the difference in the frame format. Participants in online, is it okay? Are you able to follow? Yes, please respond. Like at least give me a response in the chat. Okay. So you are able to visualize these things. So now I am just going back and changing it to bytes itself. So I have this visual thing. Now if I need to add more fields into this columns, that's also possible. So suppose I am interested in more fields in my display. So here you can see right now I just have number, time, source, destination, protocol, source port, destination port, length, info, etc. only. Suppose I am interested in more fields, I can add it over here. So defaultly, they have already given us few fields. So let's say I want to see Destination address. Okay. Oh, destination address is here, no? I'm interested in seeing. Here there is source port and destination port already. So let's say I want to see UTC time, something like additional fields, then I get to add them here. Now you can add custom also. So once you know the different field names, you can add custom names also. So instead of this, you can give custom and you can give the field. Okay. So we'll get to that. How to understand the field names, we'll get to that. Okay. So now let's start simple filtering. Simple filtering. So these are the different logical operators that is available in Wireshark. It's AND. For AND, you can use AND or double ampersand. For OR, you can use OR and double slash, then XOR, NOT. Equal to, you can use double equal to, and greater than, less than. Then we talked about capture filter and display filter. Then they have given you few example syntaxes over here. Then the different buttons like the icons, what they signify, all those things we kind of discussed. Then the different keyboard shortcuts that you can be using, then the filter commands usage and everything. Okay. See, when you go with Wireshark commands and filters, you will find you can construct huge one of this. But the best part is you need not by heart any of this. Okay. So I'll show you, like, suppose I'm interested in seeing my IP address. So like, let me figure out, I think 239 is my IP address. How do you figure out your IP address? You can go and see command prompt and you can type ipconfig and this is my default gateway. So here, see, I'm connected to my Geo Wi-Fi. So basically it's giving me an IPv6. So you can figure out your IP address, and if you are interested in seeing that specific IP address, so what you can do is, the simplest command there is IP dot addr equal to whichever IP address you are looking for. Okay. Now, /24 makes you filter in that network as well. So if you are interested in specifically just that IP address, you can directly give ip.addr equal to that IP address. Now, this will help you in filtering both that IP address as source and destination. Okay. So if you want to look at the entire traffic that was coming and going from this IP address, then ip.addr. Now, if you want this IP specifically to be source, then you have SRC. Okay. Now in Wireshark, there is one thing. If your command is not right, it will be in red color. Please listen. If your command is not right, it will be in red color. If it is right, then it will be in green color. Okay. So by that itself, you can like formulate and understand if your command is right or wrong. Now, if you want to filter it based on the destination, you have DST. Okay. So this is simple IP based filtering. IP.addr, both sender and receiver, like source and destination. If you want to filter down just based on this source, SRC, and if it is destination, .dst. Okay. Okay, I think it could be because my mic is muted. We'll talk in the end, towards the end. Yeah. So this is like simple IP-based filtering. Okay. Now, suppose I want to filter based on protocol. Okay. So then what I do is I can simply type like whatever I'm thinking of, like these alphabets. Then it gives you already the different possible keywords in the commands. Okay, that's one thing. Then the next best part of Wireshark, which I like, is majorly these kind of analysis tool has this property. Now you right click on this and you apply as filter, select it. Then it automatically generates the command for you. Can you please try that? Just right click on whichever field you are interested in. So let's say I am interested in protocol. Okay. Right click on it and you have certain options like apply as filter, prepare as filter, conversation filter, colorize, etc. So then you can apply as filter. If you want to have a selection filter, then put selected and then see it automatically does it for you. So now what happened? It's just UDP that is being shown. I don't have any other protocols. Now suppose I want to also do it such that it's UDP and destination is a specific IP address. Then I do apply as filter, then and selected. So it appends. See? It automatically generated the command for me. So UDP and destination. So now what happened? It's protocol UDP and the destination is 168.153.239. Just give a try. Try generating the commands yourself. So basically you don't have to by heart any of the stuffs. Like you can add these commands yourself. It's just practice than what's required. Participants online, are you able to follow? Should I repeat anything?
Yes, ma'am.
Yeah, thank you. Now you can do the same from these details also. Okay. So sometimes in the columns, you don't have all of the information. No? So suppose you are analyzing from the frame details and you want to do it from here. So let's say then total length is 55. You want to filter down based on that. So then apply as filter and select it. So see, and automatically IP length is 55 is appended. So from the details also you can do the same. Okay. So the summary is, even though there are a lot of fields and commands that is there, you need not by heart anything. You just sit with Wireshark patiently and analyze, you will get to know that. Okay. Now, I'll give you a task. Okay. Figure out your IP address. Okay. Now, the thing is, you have to find out all the packets which is not coming to you. So the destination is not your IP address. Just check how many packets have you received from like targeted to other devices. That's the question. So how do you do that? Figure out your IP address and destination is not your IP address. Got it, right? So you will be able to see traffic from other, targeted to other devices in your network. Just look at the traffic. You would have seen other people's traffic, like targeted to other people. $17. 150. See, you can see different destinations. These are traffic you are seeing from other devices. This in this network, you will be able to see the traffic from other people. Okay. So the like broadcasting, right? Or some kind of other traffics which is targeted to other IP addresses, 7, 0.55, all those things. See here, I can see the traffic which is not targeted to my specific IP. So what I did, see, you can write this command different way. Not IP destination equal to this one, or otherwise you can write it as not equal to this one. So basically you are negating your IP address. Then what you do? You're getting to see the packets which is targeting to a different IP address. As simple as that. So the point is the traffic which you are generating also will come into this category, right? So suppose you are accessing google.com. So what is the target? Google.com. You're getting my point, right? No?
Yes, ma'am.
Now let's access a specific packet. So open your browser. Okay. And simply search on Google search, search HTTP page with login. Simply search that. Okay. And you can take any of these. I'm just taking, oh, this is not the one. So you can take the first one, vulnerable web. Okay. So you should be able to see this thing, the warning that is not secure. Okay. So basically what we are trying to do is we are trying to simulate something. So I hope all of you open this. Now, if you are not sure of how to actually see this, so what I mean, see this specific packet that you have opened this. Now, how you can do is there is something that I always use, which is simplest filter. That is frame contains any keyword. So you don't know where to start with. Then you can make use of this keyword called frame contains. Frame contains and the keyword. Okay. So let me, what was our URL? Test PHP. See, I have all the related packets by opening that particular page. Huh? So see, it's simple string-based searching. You don't even have to give commands on the packets. Like this is a very amateur way of doing it. But if you don't know where to start with, you can use frame contains as the filter. Okay. So you get to see all the packets related to that website that you have opened. Okay. So if you would have heard, we all would have heard this, that do not use public Wi-Fi's, because if you use public Wi-Fi's, they will steal your passwords or identities or whatever your transaction is. They'll get to use that. So this was a common technique people used to do. Now what we are trying to do is we are trying to understand how these people used to steal those passwords. Okay. So in older days, it was not HTTPS, it was HTTP, right? So that's exactly what we're trying to do. Make sure capturing is on your Wireshark. Make sure it is on. Okay. Now what I am gonna do is I am going to try some ID and password on this website. So let me try some test triple M and then password. So it's not logging in, but of course, if it was the actual ID and password, still you have it captured in the packet. Now let's go to Wireshark and see how this packet looks like. Okay. So what username I gave was test triple M now. So see, I have the exact packet relating to that. Now in HTTP, you have get and post functions, right? So it's in post specifically. So it is posted. So it is post packet. So info, you can see post. Now let's look into the details. Okay. Under details, there is this HTML form URL encoded, and you can see that ID and password I entered exactly as it is. Okay. So this is the peculiarity of HTTP packets. In HTTP packets, the ID and password or the content goes as plain text. So think about the situation. Like what I'll do is, I will set up a hotspot in my device. Okay. And I'll give it to you freely. Now, suppose you were using HTTP protocol to log in and I set up a capture on my device. Then I can capture all of the packets that you are accessing, right? So if we were using HTTP even now, all of our ID and passwords will be exposed. You're getting the point, right? Please test this and see if you are able to see the ID and password. You're able to see?
Yes, ma'am.
If you're not able to, please ask, like if there is any specific step that I should repeat, I can. So this is why we say do not use public Wi-Fi's. Like what they do, even advanced, is that they'll take a clone of these traditional main websites like your Facebook, Instagram, or whatever. Like we tend to use commonly. They keep a clone of it on their local devices, and then when we are trying to access it, they don't get redirected to the actual websites. They get redirected to these ones and they harvest our credentials. And the next time, maybe it will go to the original website. So they are still able to do it. We don't usually notice that like vulnerable sign, no? Like we tend to not notice this, not secure. I mean, especially if you are opening on your mobile, we rarely notice it. Like even in laptop also, if you click on a link or like when if it is getting redirected, see if the DNS level thing is like, see, simple thing is if you are using somebody's network, okay, and if they have configured such that typing this domain should redirect to this IP, they can control it. It's as simple as that. So they can redirect the traffic to a different IP, which is not Facebook IP. So what will happen is they can get the details. So that's where people are telling use multi-factor authentication. So what happens is even if they harvest your credentials, they're still not able to proceed. because multi-factor authentication will fail, right? So now we have seen how to basically filter, how to see the packets and all those things. Now, very, very important thing in packet analysis is statistics. Okay. So there is something called statistics over here in Wireshark, where you get to see what is happening overall. Okay. So when you have to analyze a packet capture initially, so where do you start with? So the first thing that you can start with is statistics. You look at the statistics of the packets that you have. So a simple thing can be conversations. So conversations is basically the actors involved in this packet capture. Okay, so if you look at IPv4 conversations, you can see address A and B. Okay, so if you look at the total number of packets they have transferred, then the bytes they have, then the stream ID, then the packets from A to B is totally 34. The bytes is 8 KB, package from B to A is 15. So it's like you are analyzing their conversation. So in simple look, like simply if you try to filter, can you please go? Okay, so if you try to filter based on these bytes, right? So you simply are able to find out which two people had the maximum conversation. So if you want to confirm if there is a data leak, okay, if you want to see if somebody is taking a backup or like stealing information from your network, you can simply look at the byte transfer and locate the IP address which is targeting and to which they are sending the data maximum. Like today's and today, they don't send it to a single IP. They'll cluster it out. They'll send out the informations in a, I mean, a distributed manner. So those kind of pattern analysis is difficult, but still we used to see such kind of pattern where there is a data stealing. Like if you can even predict like there is a ransomware attack gonna come in because there is huge backing up of data that is happening suddenly. So if you simply try to analyze the packet and the size of information that is flowing within the network, you can get to see that. Okay. Now, another important thing is endpoints. So endpoints is again the different actors involved. Conversation was how much conversation was happening between them. Endpoints is individually all of these actors. You get a statistics about them. We do have capability to visualize their country, city, all those things and all. That is I mean, we can go on with Vaishak session for days and days also. So you can explore these stuffs. Like you can use other online databases to actually figure out what is the current city, country, latitude, longitude, etc. for each of these IP addresses as well. Then the next important field can be protocol hierarchy. So this gives you a complete statistics of different protocols involved. Okay, so I'll give you a scenario in real world. Most probably, suppose you want to analyze a network, like let it be a malicious intent or a proper analytics intent. Now, if you want to understand which is their FTP server or which is their any specific mail server or something like that. So that is required when you have a malicious intent. Suppose you want to intrude into a network and you somehow get into their network and you want to understand what is the port for FTP. What is the traditional port for FTP protocol? Huh. Others, which is the protocol? Port, FTP port. There is 2 ports. Anyone online? Yeah. There's one more. Yeah, 21, 22. So these are the traditional ports for FTP, right? Now, but in practical implementations, we don't set up these servers in 21 and 22. We set up these ports on a different, these servers on a different ports. So now if you want to intrude the traffic or like into the network, you want to understand where the FTP server is located. What you try to do is like you can get clues with protocol hierarchy. Okay. So FTP is under which family? Like FTP is it's under UDP TCP. Anyone online? Yeah, correct. So what you can notice is you will see TCP traffic, okay, but not identified as FTP traffic. You're getting my point, na? So only if it is tagged to port number 21 or 22, Wireshark will detect it as FTP. Okay. But in real world scenarios, that might not be the case. Server will be configured with a different port. Okay. To keep the ports hidden or whatever. Okay. Now, if you want to intrude into the network, you want to understand if FTP traffic is going on, this protocol hierarchy helps. Okay. So if you look at the traffic, then you will be able to see certain HTTP traffics which looks with a different length. Okay. You can analyze those packet lengths and figure out that it is FTP. So you will be able to locate the port number, and based on the located port number, you can configure Wireshark to detect it also as FTP. So how do you do that is under edit preferences, you have these protocols. Okay. So if you go to FTP here, see, here I had done certain experiments. You can add 21 or whichever port that you have configured it for the FTP. Okay. Or which you have detected as FTP port, you just add it to that, and then automatically Wireshark will start detecting that port as that specific protocol. Okay. So statistics under that protocol hierarchy helps you in understanding what is going on in this overall communication. Now let's do a experiment as a wrap up. There are so many components, but to give you a simple gist of what is going on, we'll do this exercise. Okay. In your Wireshark, TShark, TCP dump, I have an example. Here. FTP, DDoS, and Access PCAP. Just download this PCAP. Please download this PCAP. Okay, so first listen to the scenario. Okay, so I started with the scenario where the FTP server is going down, no? So it's the same scenario. Okay, so the FTP server has gone down. Now you are the network security analyst. Okay, you are given the FTP, packets which was collected, targeted to the FTP server from a specific suspicious IP address. Okay. So what you have with you is a filtered set of packets which is targeted to the FTP server from a specific IP, which the network administrator felt like is the attacker. Okay. Now, what your target is to analyze if they got access into FTP server. You understood my question, now? You have to understand if the FTP server was compromised. So, see, when you try to analyze something, it is very important to formulate questions. Okay. What are you looking for is a very, very important thing to do. Okay. So first question, in this case, I'm giving you the questions, but when you are analyzing, you yourself have to formulate the questions. Now, in this specific scenario, the first question is to understand whether they have compromised or like FTP server was the only target for this attacker. Okay, so that's the first question. How do we confirm that? We can look at the conversations. Okay, so look at the conversations and try to confirm if FTP server was the only target. First question. Second question is, did they compromise the FTP server? Which means that did they get access into the FTP server? Okay. If yes, what methodology did they use? Methodology in the sense, what technique did they use to get into that? Most probably it will be brute force only, like because FTP is like plain text, you can directly find it out from there. So if they did get access, like which user ID did they compromise? Okay. And the third question is, did they steal any information from the FTP server? Did they download anything? Okay. So these are the questions you have to answer. No, it's a PCAP only. It's a directly a PCAP file. No. I was talking about this one. This document. Wireshark, Tshark, TCP dump document. This document. Under that, you have something called example. I have shared Wireshark, Tshark, TCP dump. Should I share it again? I can. In the same link. Not the Google Drive. I shared 3 files. One is Google Drive. One is a document. Next is a cheat sheet. Are you there in this Teams? Are you guys, any of you are there? I think it's there in your WhatsApp.
Ma'am, it is open.
One of them is that only. Open it, please.
To open the drive is not there.
There is one more file.
No, ma'am, we share only one link. One
Please download it and just open the file. Just double click on it. Automatically Wireshark will detect it. And you should be in the file. Now the first question was if FTP server was the only target. So you can simply go to TCP traffic and look at the ports that they have targeted. And here you can see the port 21 is a major target. And here you can also see that they were doing a port scanning. They scanned with 1, 3, 4, 6, 7 likewise. And then they reached 21, which they found out as open port. And then they targeted it and they were completely executing the remaining communication over port 21. So where did I go? Conversations, under statistics, conversations, and TCP. And you can sort based on the port. Are you able to see? No? Did you open the packet? So we can confirm that they were targeting FTP server. That's clear. Now next question is, did they get access into FTP server? How do you check? You can use the combination of name contains. You can check for success, user logged in, login failed, authenticated, those kind of frames, like if there is a success message. Or otherwise, the correct way to do it is like you will have to look at the FTP protocol format and you have to understand what is the response for when the user is successfully logged in. So based on the protocol that you are trying to analyze, there is a success message code to 200, not 200. Yes, this is great, Grishma. Like you have detected that they are attempting to brute force. Now, next target, what you can do is you have to see if they successfully logged in. What is the success code for FTP? See, for every protocol, there is response codes. To analyze Vaishakhs, we need to have a little bit of knowledge on response codes also. I'm just introducing these concepts. So response code, you can see simply like HTTP response code. We get that 404 and all, no? In page. Similarly, there is like simply search HTTP response code. So you have got the response codes for successful login. Now you don't know the command, right? So simply type FTP dot. It will give you all the options. So here you can see FTP dot response code equal to 230. Now we have checking if there is a successful login. We got it that the users have successfully logged in. Mean the attackers have logged in. Now to understand which account they have used, you right click on that and follow the TCP stream. So here you can see that they have logged in using the account called Anon. So what did I do? I found out FTP dot response code equal to 230 and I specifically found out that particular packet. Now I'm right clicking on that and I'm doing the TCP stream follow. So here I can see what happened around that packet instance. Okay. So here we can see that the attacker was continuously doing brute force and they were trying with different accounts, and finally user Anand was successful. But in this particular packet, you cannot see any data stealing, right? You don't see anything. They just logged in. So there was one more packet which looked suspicious, no? So let us go to the other one, FTP 230. Second one, and then I follow. So here I can see so many things that has happened. I can see that they have transferred something. Okay. So which confirms that the attacker has logged into the FTP server, plus they have stolen the information as well. Okay. Now there is one more thing I want to show you. So under statistics also, you will be able to find this out. So if you go to conversation, if I try to sort based on the packet, sorry, byte size. Okay. So here you can see how different this is. See, there is a packet with a very large byte size. So when we are analyzing conversations, first thing you can do is also this one. Traditionally, packets will have certain size, but there is one packet which is having a size of 179 KB. So you can inspect that. Apply as filter, select A to B. Directly you can go to that packet here. Okay. And then you can right click on it. Follow TCP stream. You can see the PNG file that they have transferred. Now there is one more thing. You can actually download it. So what you can do is you can download it into raw format and save as. I'm saving it to my desktop and seeing like test FTP file and save. Then I'll be getting it as I can just open my desktop and see the file. What is it? So it was a PNG file which I could understand from there. So I am opening, let me open it in Paint. See, this is the file. So how did I understand it was an sorry, PNG? I had it in this. See, TCP stream. When I looked into ASCII format, it had .png. That's right. Okay. So this way, Wireshark, with Wireshark, you can actually download the objects that is involved as well. Okay, that's it. Now, one more thing, like last thing, in the exercise folders that I've given with you, there are few other exercises as well. You can try and do that. And if you have any doubts on them, you can reach out to me. Like if you have understanding the exercise also, you can reach out to me on LinkedIn or wherever mediums. Like you can find my name, Mahima Mary Matthews. So this is just a brief touch, like with 1.5 hours, we will be just able to cover basics only. So I've given you few exercises in that drive. You can try and play around with it. And if you have questions, always welcome. Thank you.
Oh, to the online participants, if you have any doubts, please, you can unmute yourself. Okay, hope. Offline participants, any quick doubts you can ask? Okay, we are okay, fine. So we extend our heartfelt thanks to Ms. Mahima Mary Matthews for insightful practical session. Your session provided a valuable blend of theory and real-world application, offering us new perspectives on monitoring and securing network environments. We are grateful for the depth of knowledge you brought to the session and for engaging the participants so effectively. Thank you, ma'am. Thank you for the session. We'll be resuming our next session after 5 minutes. We are going for a tea break and we'll resume the session. Okay, thank you. Welcome back, everyone. Next, we are going to the next session. We are pleased to welcome Dr. Kopala Guruvaya, Assistant Professor at IIIT Kottayam, who will be taking today's session on applications of IoT with privacy and security. Before we begin, let me briefly introduce our esteemed speaker. Sir is currently working as Assistant Professor in the Department of Computer Science and Engineering at IIIT Kottayam. He completed his PhD with a scholarship from the MHRD NIT Tiruchirappalli. He completed MTech in CSE with a scholarship from MHRD and BTech in CSE from Andhra Pradesh. He completed 5+ funded projects. He has 10 years of teaching experience. His expertise lies on networking domain, focusing on security, routing protocols for WSN, IoT, SDN networks, and real-time applications, solving using IoT technologies with deep learning and machine learning. He has published 13+ articles in reputed SCI Scopus journals, 5+ Scopus conferences, and 5+ Scopus indexed book chapters in the field of WSN and IoT. He is a reviewer of peer-reviewed reputed journals and IEEE conferences, and his professional memberships include IEEE, IAENG, ISTE Life Member. We welcome you, sir, to the session.
Thank you.
Yeah. Good afternoon. So I hope it is audible for the online audience also. Can you give any response from the online audience? Is it audible or not?
Audible, sir.
Yeah. Fine. So maybe the topic today is applications of IoT. Mainly concentration is how we are going to develop and applications which are daily the different kind of activities you people are doing. So we'll consider those applications and maybe we'll try to implement those things with the help of IoT, and maybe we'll think about the privacy and maybe the security concerns with respect to those applications. Fine. So coming to the maybe this one already currently people are here, so no need to explain about the my college, what is current my role and other things. And maybe currently we are having the lab here, a Swings lab. It is a smart wireless internet networking group where we are doing different kind of projects with which includes IoT related applications and maybe some kind of translators, as well as IoT related some kind of projects we are doing for a different kind of applications for maybe home monitoring and maybe the vehicular monitoring and other stuff. Fine. So we'll come to the presentation. So what is the requirement of IoT and maybe why we required? What is the necessity of IoT? If you are considering, so that's what we are going to discuss here. And so what we can do with the IoT and what additional things we need to give to the IoT so that it will be more flexible as well as user friendly, and same way it should be the kind of activation without the user user perspectives. So even maybe the user is not willing, he is not able to do the task, but your system has to do by default. Maybe consider the examples. For example, so daily morning, your son or maybe daughter bus will come. It will start from 8:30 to from my home. Home. It will reach to the school. So you need to monitor your children's. And it is too difficult to you while you are doing, or maybe while you are doing some other work outside, or maybe you need to do that work to survive the family. So while you are doing that one, you need to check your children's activities, whether they are going to school, or whether they are fine with the activities, or maybe they missed the bus, all these things. Now they consider maybe what you can do with the IoT thing is, now maybe early morning while you are waking up, you need to make ready your daughter or son. Then you need to take him to the bus stop. Then you need to get into the, then you need to make them to get into the bus. Then we need to send them. After that, you need to come back and you need to get ready and you need to start coming to the college. So this is the daily activity of mine. So daily I need to wake up and I need to make my daughter sons to be ready to the school. Then I need to take to the bus and I need to get, I need to send them to the bus. Now the difficulties what we are going to get is the problem one. So when bus will come? Maybe 8:30 bus people they said. So whether exactly 8:30 daily bus will come? So that is one doubt. And second doubt is whether we will be ready by exactly 8:30. So that is also difficult. So now what they are making, so by exactly maybe when bus will start from the first stop, then they are going to send us one GPS location. So now you can think about the bus where exactly there. So now based on that, you can make your daughter get ready and you can take exactly bus before 1 minute or 2 minutes it is coming to my bus stop. So I can take them to the exactly bus stop and I can make them to get into the bus. Right. So this is the one simple application you can think. Now, this is the case. How you are going to monitor where exactly bus is there? So you need to get some updates with respect to that. Bus started 8 o'clock. Currently, this where exactly that bus is there. And maybe same thing evening also. You need to collect your children. So same time when it is starting from the bus, it is starting from the school. So whether your children get into the bus or not, you need to monitor. Maybe these are the simple applications. So what we can do, maybe recently, even where my daughter is going to school, they introduced GPS location of the bus. Okay, one is. Maybe another way is GPS location they are updating to me. Automatically, I can make my daughter get ready so that I can take exactly to the bus stop. So what is the need here? Reducing the waiting time, right? So you need to reduce the waiting time of your son or daughter to go. Same way, I have after that maybe 8:45 I am making my daughter into the bus. After that I have 9 o'clock class here. So what I need to do? I need to rush away. So accordingly, whenever you are waking up, maybe daily activities, your water heater should switch on, and maybe some kind of other activities, automatic activities should switch on. Maybe once I am getting out the bed, my water kettle should heat the water. Right, irrespective of now, once if I am waking from the bed, automatically my water kettle should switch on and it has to provide when I am reaching to the water kettle place. By that time I should get proper water. So irrespective of my response, daily what we used to do, we used to wake up and I used to go and fill the water bottle or maybe fill the water kettle. Then I need to switch on the water kettle, then it will be get heated. Instead of that, automatically once if I am getting out the bed, automatically my water kettle should make heat and that water should be given to me by ready. I mean, it should be ready so that I can go and take. And after that, maybe I will take some 10-15 minutes walk. After that, I will enter into the bathroom. So by the time my water heater, if it is making ready with hot water, or maybe I need to switch on, either what will be the case. So today morning I switched on the water heater. So now no one is there in my home. So I forget and I came out. Now it will be on only. So now when I will go into switch, so it is going to be the power consumption and maybe other failures may happen. So now to avoid that one, whenever I am getting up the bed and maybe I am taking some 15 minutes walk after taking water, by that time my system should analyze and automatically it should turn the water heater. So once I entered into the bathroom, so I can take the bath and I can come out. So by that time I will get ready. By that time maybe my bread roaster, it is going to prepare my breads and it is going to give it to me. So I will take that one and I will get down. So by the time now currently the current trend with respect to the vehicles is automotive vehicles. So automatically if I am getting into the vehicle, it has to take to me what is the destination I am saying. So I am saying maybe go to the academic block 2. So daily I used to drop in the main gate itself. Instead of that I need to come here because I am having class today here. So by the time exactly it has to take to me here instead of stopping there itself. So these are the different kind of activities you can take into the consideration. So how we are going to implement those kind of applications with the help of IoT, where the consideration is what is the requirement of AI/ML/DL here. So without AI/ML/DL, what you are going to provide. So those things we are going to see here. And for that, we required a sensor network or it may be different kind of sensing devices. So what is the sensing devices with respect to our application? Maybe with respect to the, I need to send my daughter to school. So what is the devices it has to work? So the GPS, which is located inside the bus, which is coming on to the my path. Maybe that bus should respond to me. That vehicle, that bus GPS should respond to me. Currently, I started from this location. You be ready by that time. So I can check, I can track that bus and I can take my daughter by correct time and I can take into the bus. That is one thing. Maybe second scenario is you may consider here with respect to sensors where whether I am getting up from the bed or not. So that is the first constraint I need to take. If I am getting up, my water kettle should switch on and maybe it has to get heated the water. And maybe whether I get up from the bed or maybe I am ready to get into the bathroom so that my water heater should switch on and it should get heated the water and it should be ready when I am going inside the bathroom. So these are the two scenarios you can consider. So how exactly it is going to happen? So for that we require some kind of sensors. Maybe consider here GPS is the some kind of sensor which is going to check what is the current location of you. And maybe another kind of scenario here may be how we are waking up from the bed. So your bed should have some kind of sensors and what will be the weight of the bed, maybe on that bed. Currently weight of this one, if I am sitting on the bed, what will be the weight? So some kind of sensor it has to activate. And once that is getting free up or maybe your weight is reduced from the bed. So automatically what I am going to take? I can give the alarm to my water heater as well as the water kettle to make up all the things are ready, right? Automatically by that time, once I locked my door, maybe my main door, automatically my car should come to the correct place where I am going to get in. Instead of the parking area, it has to come to the entrance of my door and it has to stay. So that once if I am getting and I am setting the from to where I need to reach, automatically it has to find it out the path and it has to reach. So for that, there are so many sensors has to work together and it has to give accomplished. And same way, while you are doing this kind of activities, you need to take some kind of maybe now the case is when I should switch off my water kettle. Right. So maybe daily I used to take maybe 70 degrees or maybe 60 degrees of water, heated water that I can take. I cannot take more than that heated water. I need to make some, little bit cool, then only I need to take. So now in that case, so it has to identify what will be the daily scenario. What is the heated, maybe foreign heat, how much we are heating and how much he is able to take. Based on that, it has to heat. So no need to take much heat and maybe no need to consume much power to make it heat. So that is maybe the another scenario here we are going to consider. Right. So how we are going to make these kind of things. So for that, how exactly your system should analyze what will be the heating temperature I need to provide to the water so that he will consume without any kind of problems. Right. And same way, maybe you can take so many other applications. Now the vehicle which is moving from my home to here, it has to identify the path and it should be free. Right. So because there is, there is a driverless vehicle, so automatically it has to find the path, it should be free and it has to come. So it should not create any kind of other problems to me. So by the time I have 9 o'clock class, I should reach before 9 itself. Right. So what kind of things now it has to find it out, what is the best route to reach here and whether that route is free or not, everything it has to find it out. For that, we require some kind of artificial intelligence and maybe some data gathering background to find it out whether this route is free or not, and some kind of connectivity, and maybe for finding whether this route is free or not, maybe we require some kind of machine learning or maybe deep learning algorithms. Right. So then we will come to the scenario with respect to the why we required IoT here. So there is a small difference between WSN and IoT. So what is the difference? We will come together, and then we will see there are two applications. One is maybe the vehicular monitoring. So now, for example, you have your own car and you are taking that one. So suddenly maybe your son or maybe your daughter took, and maybe they are not having license. So what will be the scenario? So whether you should get some kind of alert message. So your son or daughter or maybe someone who is driving, he is not having the license. So he is driving the vehicle. So some kind of update if I am getting, so I may be careful with respect to that and I may alert that particular person with respect to that. Or maybe sometimes without your intervention, someone came and took your vehicle. Maybe some kind of theft happened. So some thief came and took your vehicle. So that time I should get alert and who is driving your vehicle? What is his current location? So that's what maybe we are going to discuss here with respect to the vehicular monitoring, and maybe the home monitoring also similar kind of concept. Maybe if no one is there in your house, maybe some elder people are there, they are unable to move in your house. So now how we are going to protect from the unauthorized users to your home? So what kind of things you are going to provide? So that's what we are going to check with respect to the home monitoring. So that's what maybe here with respect to the security, how I am going to provide these applications, how I am going to solve these applications for security reasons. Okay, so it's not completely with respect to the security protocols or maybe other things. It is general kind of application with the help of IoT, how I am going to provide those security and other stuff. Fine. So now if I am considering with respect to the IoT, okay, so what exactly the IoT? It is a collection of different kind of sensors. And the main goal of IoT is to solve some specific task. Maybe the IoT, this is also kind of IoT device. So this, what is the main purpose of this particular object? So it is going to provide you, and maybe now it is taking my voice and it is translating and it is going to give it to you. Maybe consider here, sometimes we are having a different kind of, maybe you have the headphones or maybe your headset. So that headset is having automatically, it is going to convert the language. Whatever I am speaking, so that should be converted to your own native language. Then if you are listening, it will be good, right? Maybe if you are taking any kind of flight, mostly you have different kind of, the TVs, what they are providing in front of your seat, it may have different, a similar kind of setup. But they are having earlier with respect to the movies which are there, it is specific to the language. Now maybe sometimes they will explain to you that if you are keeping the headset, they will provide to you what language you are preferring. So now what we required here, whatever I am speaking, it should be audible to you with respect to your own language. Right, whatever I am speaking, maybe in that case, I can speak my own native language so that it will be audible to you in your own native language. So no need of the barrier with respect to here, no need to think about the language barrier. Right. Otherwise, what we need to do, we need to learn almost all people English so that I can speak in English, you people are able to listen. So instead of that, I can speak in my own language. That should be converted to your own language. So that kind of system is there. It will be good, right? So that is also kind of now this mic is taking my voice and it is going to be amplified and it is going to give it to you. So now how it is doing, that's what here maybe the kind of devices what we are having here. So maybe the main goal of IoT is providing the secure communication between the vehicles or maybe between the people and maybe the devices what currently working with respect to that. Fine. Now, what is the main purpose of thing is to exchange the information. Why we need to exchange? To communicate. So maybe you can exchange lot of different kind of messages. Maybe according to this presentation, we are going to exchange maybe with respect to the monitoring the houses to prevent from the theft. Maybe home monitoring you can do with respect to how we are going to monitor. Or it may be every 15 seconds, I need to monitor what will be the temperature. So now you are feeling any AC is there in this room. If it is there, it should be there. After some time, it will be reduced. So now maybe automatically once it is reaching to the 17 degrees, your AC should switch on, switch off automatically. Once it is reaching to 28, then it has to switch on automatically your AC. So that is also kind of taking the input, analyzing, and maybe giving the output to you. That's what we are going to do with respect to. So now what is that exchange of messages? First, it has to take the information from this room temperature. It has to analyze. Now whether I need to switch on the AC or I need to switch off the AC. That I need to take and I need to give it back to you. Right? So that is the exchanging of messages. So while you want to take this one, so automatically you need to provide the features which are connection reliable, because now your AC should speak with the room. Right? So your room means indirectly what will be the temperature of the room. So that temperature sensor has to speak with your AC and it has to switch on. So there is a communication between the people to the devices to the another devices. That's what we are going to take here. Right? So now while we are providing these kind of things, so we should have to provide, these are the features. Maybe one is connection reliability and maybe latency also you should minimize. Maybe for example, my daughter bus, it is going to come to my place is 8:45, but I got the message by 9:30 only. So your bus will come by 8:45, you be ready. So that message I got by 9:30. So is it good? So automatically bus will go out. Right? I need to plan for other alternative process. So to do the activity. So that's what may be here. So the latency should be less so that I can be alerted with respect to that message. Right? So those are the different kind of features we required. And same way, there are so many different kind of applications. Maybe there are 2 or 3 applications we discussed now. You can maybe analyze or maybe think. Maybe you might have not thought previously. So this is also the application you can do with the IoT. But now you can think maybe what are the applications we did. Maybe similar kind of applications you may produce and you may get good results with respect to that also. So for doing these things, we required, these are the features, maybe wireless sensor networks we required, and maybe why we required these wireless sensor networks, we need different kind of sensors to sense the field or maybe sense the environment, and it has to give some kind of input. That input, based on that input, your AC should switch on or not, or switch off or not, that I need to take care. Right? So same way, while I am taking this one, so I can use some kind of the other technologies, AI, machine learning, deep learning to take the activity when I need to switch on the AC. So for this particular application, if temperature is lesser than 17 or maybe it is equal to 17, I should switch off the AC. If temperature is equal to 28 or maybe greater than 28, I should switch off the, I should switch on the AC. So this is the simple operation. Now consider here, there will be another kind of scenarios. Now, with respect to now the person, currently I am not there in the home. Maybe my grandmother is there in my home. Now, who is coming inside my home? Maybe someone is waiting in front of my home. So I need to get alerted with respect to that. When he will come, whether you have any time, fixed time, we don't know. We don't have any kind of time. Maybe nowadays we are getting more than maybe generally how many times we are entering into the house, more than that Amazon people are coming or maybe Flipkart people are coming. Right? So we need to monitor the presence of the other people in front of your home. So now when they will come, so there is no fixed time, right? So your system automatically has to identify who the persons who are visiting your home, whether they're known to you or unknown to you. If they are known to you, you no need to get any kind of alert. If they are unknown to you, then you need to get the alert. And how many times we are going out and coming inside the home per day? It will be more number of times. Even though your system should not say anything problem, or maybe your system should not create any kind of problem. Any number of times you are going and coming out. Alright, you are going out and maybe coming in, it should not raise any kind of problem. Maybe if at the same time, if any unknown person is coming with you, it has to identify and it has to send the signal regarding that particular person. So this is the guy who came with this particular person, or maybe he came alone by this time in front of your house. So is it you know him, or maybe it is some unknown thief, he may enter into your house, or maybe anything else. So I need to project. So in that case, I require some kind of intelligence with respect to that. So your sensors may give you the results, or maybe the data which is presence in your environment. After that, you need to take some kind of intelligence. How you are going to find it out whether this particular person you know or not. I need to find it out. So for that reason, we need to use these AI, machine learning, and deep learning technologies. So that's what maybe I'm not going to explain much with respect to this AI. I think maybe yesterday classes. So these things and all already happened here. So this is the normal structure of this deep learning and maybe machine learning and artificial intelligence overall concepts. So maybe we will consider with respect to the wireless sensor networks. So what is sensor network here? Now I hope you understood what is a clear picture about this presentation. So there is a application we are going to solve maybe with respect to the home monitoring, or maybe I need to find it out whether who are the people are using my vehicle, whether they are informing to me earlier, or maybe without informing to me they are taking my vehicle. So that's what, maybe with key they are using or without key they are using. So that I need to find it out. So for that we required some kind of sensor nodes. So maybe we'll consider here the sensor nodes is nothing but here a distributed, maybe the sensor network if we are considering, it is distributed in nature. So there will be so many number of lightweight sensor nodes which are distributed in the field and maybe environment. Now I need to find it out. What will be the temperature in each and every room? Consider here we are having all the rooms maybe air conditioner. So I need to check how many air conditioners currently switch on, and maybe what is the room temperature of 888 time. Everything I need to monitor. So now how many sensors is required? Is it required only one sensor which I am keeping entrance of the 888 time? So that itself it is fine to calculate all the room temperatures? No, right? I need to implement so many, I need to keep all the sensors in different kind of rooms, and I need to find it out what will be the room temperature of each and everything inside 888 time. Right? So I need so many different kind of sensors which are lightweight and small, and which are deployed in a large number. So that depends on the application here with respect to the large number. So maybe consider I need to monitor the forest. So anywhere forest fire is happening, maybe this is forest fire is general in Tamil Nadu and Andhra border. I mean Andhra, because of the temperature conditions, it will be huge now current time. So maybe May, April, up to June it will be huge. After that, maybe once rain started, it is going to reduce. So now I need to find it out what is the forest fire related activities are happening in a forest. So whether we are going inside the forest, we are not going, but we need to find it out what will be the wildlife concepts with respect to this fire. So whether any animals are affected with respect to this kind of fire, or maybe how you are going to protect, or maybe it is going to create any kind of problem to the people who are surrounding of that forest. So all these things we need to monitor. So now with respect to the forest, I need to keep on calculating. There will be, it is not located maybe with respect to the forest. I cannot say it as a with one or two trees size. It will be a bigger land, maybe 10 acres, maybe 100 acres, 200 acres. So now how we are going to monitor that one? So I need to have so many sensors, and those sensors will monitor the environment or the system. So now you can think what kind of things it will monitor. So it may measure the physical parameters. It may measure the physical activities, or it may be even your camera is also going to consider as a one kind of sensor. So it is going to be visual sensor. So it is going to visualize what are the things are there in that particular field. right? So now I need to visualize all these things. So that's what maybe the different kind of sensors you may use, and maybe there are two ways these sensors can be used. So generally, your mobile phone, consider maybe there is no network in a particular area. What is that means? If there is no network, maybe in this lab, maybe we have a doubt with respect to idea, we have any internet connectivity here. So if it is not there, so what is the meaning? So this is unable to connect to the other people, or maybe it is separated from the people. Why? Because there is no connectivity provider. There is no connectivity provider which can create the communication between you and the other nation. So that's what we are going to have. So now we need to think about how we are going to provide this connectivity. Always this is not possible, right? Now once if I'm keeping the sensors, so it is not with respect to the IP addresses. Maybe your own IP address you are going to create there with respect to the identification purpose. So in that case, it is too difficult. So now I am going to use two ways the sensor nodes. One, it is going to generate the data and it is going to spread across once it is generating the data, it is going to spread to the society. Now, once if I am generating, I need to spread. So how I am going to spread? Whether I have any connectivity nearby, that is fine. If it is not there, then the sensor node itself, it is going to activate as a router kind of thing. So it will take from other sensor and it will forward to the next sensor, which is near to the base station or maybe to the server, so that I can collect the data. For example, I have the server in this block. Okay, now I entered from the entrance. Now automatically the data which it is generated, the camera which is located the entrance of the gate, it should send who entered at what time, should send to the server. Now there is a very big difficulty how I am going to create the connection between the server node to the sensor node which is located. Either I need to provide wired connection or maybe wireless connection. So now once if I am coming to the sensor networks, it is completely wireless related things. So that depends on the application. Maybe we are we are deploying the sensors. Maybe forest, we cannot keep the wires and we cannot monitor, right? Once if you are able to do that one, we are making that one, maybe no need to think about the power failures and other things. That's what we are going to consider here. So there are two ways you can make it as a node or maybe sensor node in two ways. One is it is going to generate the data. Another one, it is going to forward the data by receiving from the different nodes. So this is the simple network. Maybe you can monitor a different kind of things. Maybe we'll display something else. Fine. Now we'll come to the what is the difference between your wireless sensor networks and IoT. So majorly they are going to specify not with respect to the maybe a general specific way is wireless sensor networks. Maybe I am monitoring IIIT Kottayam. So I am not going to share any kind of details to the IIIT Kottayam. I mean out of the IIIT Kottayam, I am going to share the details within this college itself. I don't want to share this information to outside. So if I am sharing, it will be different perspective, right? So I need to share only within this one. So in that case, for me, only wireless sensor networks is fine. I don't want to connect to the internet. I can collect the data and I can keep in my server so that I can protect that data with respect to me. And I don't want to share to the outside. And maybe if you want to share the details, or maybe sometimes this cloud technologies will come into the picture to store this data. Because now, for example, I am generating the data. For generating this data, how many cameras I need to keep? Maybe consider how many cameras you are thinking in this campus are there currently working. 40? 20 to 30. So how much data it will generate per day? It is monitoring, right? Directly, daily it is monitoring from morning 12:01 to midnight 11:59 or maybe 12. How much data it is going to generate per day, one camera? That depends on the size, the capacity, right? So how much resolution and other stuff. Maybe consider each camera is going to generate, web camera, it is going to generate 500 MB per day. Right? So now I have one hard disk. I connected one hard disk. Now maybe consider maybe 50 cameras are there inside entire campus, or maybe 100 cameras are there entire campus. How much data I am generating per day? 500 into 500 MB. So around maybe 250 GB. Right? 250 GB of data I am going to generate. So this 250 GB, now I have 1 terabyte hard disk. How much data you are going to store? Only 4 days data. What about 5th day? You need to purchase new device or you need to erase earlier data. Right? So now consider you went to one shopping mall, you purchased something, and while you are coming back with hurry or maybe with your children, you forget one bag there. And you realized that bag after 5 days. Now what will be the scenario? Maybe consider same scenario here. I can store only 4 days data. 5th day event. So what will be the scenario? How I am going to find it out? My valuable thing. Consider there inside we have a gold and other stuff. So then it will be very valuable, right? Yeah. So what will be the case? Now it is too difficult to find it out. So they will say, we don't know. We don't know. We didn't get any kind of such pack. So that's what they will say. Now, even if you are asking, so open your web cameras and other stuff, they will redirect to you some other way because they are not storing that much data. Right? What you are going to do for that? So those are the different kind of things. Now, what they are doing, so because of the limitations with respect to the storage, they are directly using cloud services. So there you can use. So now that cloud services, how we are going to connect? We require internet. So there maybe it is having some kind of IoT related thing. So once if you are storing into the internet, so there is once again you need to think about the privacy and security issues. Right. So the privacy with respect to that, maybe I entered inside the some shop. So they took my image and they kept in the internet. Indirectly, it is going to the internet itself. Right. So there is a privacy issues. That how we are going to handle. So that is the another responsibility of IoT to handle those things. Anyhow, we are going to discuss some of the applications with respect to that. So these are the some tools we are going to use for these applications. So these are the simulator tools. Maybe currently we are going to avoid. Maybe these are the NS2, NS3, MATLAB, UpNet, NetSim. These are the some simulator tools. There you can deploy the maybe yesterday you got some Cisco packet tracer, right? Where you can design some kind of network and you can collect the information. Similar kind of thing you can do with these kind of simulators also. Apart from that, we are going to discuss some software and hardware related things. So those are very much cheaper nowadays, and it is very easy to implement and do the some kind of real-time exposure with respect to the applications. So for that, we are using maybe Raspberry Pi and Arduino, BeagleBone. There are 3 different kind of models I am showing here. And maybe for that, we are using some kind of software here for Raspberry Pi, Raspbian OS we are using. And maybe here even you can use Tenai OS and maybe Contiki OS. And Arduino IDE used for setting up the Arduino board to write code and maybe do some kind of activities with respect to the Arduino. So that's what we are going to do here. And maybe these are the hardware devices. In addition to that, we need, so now we discuss so many applications. So these are the some kind of sensors we required. So that's what maybe I said to monitor your home. So who is coming inside your home and who is going out? I need some kind of camera there. And same way you need to find it out with respect to RFID. Where and all you used RFID? I think maybe once if you are going to the school, somewhere maybe college, you might have used that RFID. Where you used it? Library management system. Where if you are opening your book at the end page, there will be an RFID which is attached to that book. So that RFID without entering inside the data, and if you are going out, it will be giving some alarm. So there will be a RFID radar will be there. That radar it will identify. Once if it is identifying that radar, so it will identify and it will try to match with the database. Whether this ID is already registered with me to go out or it is not registered. So if it is registered, it will allow. If it is not registered, then it is going to raise some kind of alarm. That's what it is happening with respect to your library management system. Maybe other devices, if you am taking, this is going to be the Zigbee, where if you want to provide some kind of communication. So 802.15.4, 2.15.4, so that it is going to provide some kind of communication between devices. Maybe consider the camera I kept there in entrance, and maybe my server is here. How I am going to communicate? Either I need to provide the entire, half-kilometer wire, or I need to provide some kind of wireless communication. That communication I may provide through using this Zigbee board. And maybe like that, we have, this is going to be the temperature and humidity sensor. and maybe this is going to be the ultrasonic sensor, ultrasonic distance sensor. It is going to measure what is the distance between you and the object. For example, I have the sensor here and I am walking. Automatically, if it is able to detect this particular pipe, automatically it will instruct to me. So some object is there in front of you, be careful. Okay, so such kind of device. So this is going to be it is going to provide the internet, and these are the some, I can say it as a gas sensors. It is going to measure different kind of gases, maybe your gas leakage, LPG gas, that is also going to detect with the help of these sensors, and maybe whether CO is, what is the level of CO in your vehicle, CO2 in your vehicle, all these things we can measure. And these are the some different kind of sensors we use it for our own applications here. So there are different kind of applications you can think, maybe already you might have got idea. So what are the different applications we can do? So whatever we thought here, those are the daily activities, right? Even you can think about your own expense. So now you are going from your home to the college. So what will be the distance? What is the path, best path you need to find it out. So which route if I am going, I will get the perfect, I will reach by this time. So all these things you can have with respect to this. Whatever applications if you are taking, so the major events with respect to application is you need to find it out what is the event detection. So what is the event detection? Maybe for example, I need to find it out with respect to my AC should switch on when it is reaching to 28 degrees. When it is reaching to the 17 degrees, it has to switch off. That is the event it has to keep on monitoring, keep on identifying whether it is reached to 17 or not. Once if it is reached, then I need to switch on the AC or maybe switch off the AC. That's what we are going to take. And this is going to be the periodic measurements. Maybe for example, if you are calculating the temperature inside my college. So now if I want to calculate, measure the temperature, so what will be the scenario? Whether you need to monitor each and every room. Overall, what will be the temperature inside IIIT Kottayam I need to monitor. Okay, so in that case, I don't want to monitor all the rooms and I don't need to keep, right? One sensor which is going to provide to you. And maybe that sensor from morning 12:01 to night 11:59, it has to work, no need. So it can give maybe periodic measurements, maybe what is the situation with respect to 2 o'clock night, and maybe morning 8 o'clock, what is the temperature, or maybe 6 o'clock, then 9 o'clock, 11 o'clock, 2 o'clock, like that it can give maybe periodically, it will give some kind of options. And maybe another thing is here, this periodic measurements, you may consider with respect to the application to application. So either it is going to be periodic measurements or it going to be the event detection. It is going to keep on checking for the event whether it is going to occur or not. So for example, at the entrance of the gate, who is entering? So is there any particular time will be there to enter and go out? No, right? So anytime they can enter and anytime they can go out. So I need to monitor not periodically, continuously I need to monitor and I need to find it out. Whenever object is coming, whenever person is coming inside, I need to find it out his time, when he is entering into the time and when he is leaving the college. So that is the only the perspective with respect to, maybe this is the applications we can consider with respect to your colleges. Right? So now, so what are the operations are there here? Now you need to collect the data. Once if you are collecting the data, what you are going to get, so you need to collect the data from generally the sensor node to the base station or maybe the server. So there exactly finding the path between the sensor node to the server is a very big task in wireless sensor networks when compared to just sensing and getting the data. So if one particular sensor, if I am fixing here, that sensor main role is to sense the data. What is the temperature of this room? That will be very easy. But now it has to, this particular sensor has to identify to whom I need to send the data. What is the best path to send the data? Maybe the server is in, kept in the academic block 1. So now I need to find it out the path from here to the server, which path if I am sending it will reach to the fast. And maybe now some fire accident is going to happen here because of the temperature fluctuations. It was 28, suddenly it increased to 40. Before I'm switching on the AC, it suddenly increased. Now I need to monitor and I need to switch on some kind of other water spillers so that it will cool the entire room. So now for that, automatically it has to recognize and it has to give some kind of activity there. So it should, so now how this water pillar should switch on? Automatically it has to take from the data whatever we are collecting from the room. right? That's what we need to do. Otherwise, what we are going to do, we will send the data to the server. Server will check and maybe he will reply. Now, when I send the data, he went for some maybe some washroom or maybe for getting water, and he came back. By the time fire accident happened. So it is too difficult, right? So by default, it has to measure and it has to give the option to you, or maybe it has to act according to the current situations. So those things you are going to do with the help of this one. But here, the majorly sensing data is not much creating the problem with respect to the energy. But while I am finding the path, I need to send to the server. Server has to respond to this. Now currently temperature is 40 degrees. So by default, my sprinkler should switch on so that my room get cool with respect to that instead of fire accident, or maybe suddenly some fire happened. So I need to cool that one. So what way I can make it cool? So instead of maybe some people are coming, I am going to alert the people. Instead of that, automatic system itself, if it is taking, it will be good objective, right? So that's what we are going to do here. So forwarding the data to the base station is creating much more problem here. So that's what maybe even while you are forwarding the data, there are two ways. One is sensor node interest. Another one is server interest. If it is sensor node interest, that is going to be the data dissemination. If it is data gathering, your server is collecting the data. So that's what may be the data gathering. Where data dissemination is sensor is sending the data. Maybe consider with respect to the job applications. Now they will put one notification. So company is keeping some notification. So I need the persons who are having 75% more than aggregate of the percentage, and plus who are interested with respect to the IoT. So now depends on these two cases. This is my interest. So that's what maybe I am planning to give some kind of notification. Based on that notification, you people are responding. Okay, I am interested. I have this much experience with respect to these kind of applications. So I may eligible to this one. So that's what the reason I am applying. So that is what we are going to consider here. Your data disseminating. Initially, I am disseminating the data. So I need this kind of data. Anyone is there. Now you are going to give it to that. Right. So that's what may be the difference between data dissemination. It is going to be with respect to the sensor node side. Whereas data gathering, it is going to be the server side. Who is gathering the data? Who is sending the data? So that's what the concept with respect to these two things. Right. So now, if you want to do these two things, any one thing should communicate. Any one thing should happen here. Either I can directly transfer the data, or maybe I may forward the data to my next hop. That hop will take the data to my server. That's what I said. Maybe the server is located here, and maybe sensor node at the entrance. Now, how it is going to send the data to here? So it has to send to the intermediate node. That node will find it out the another node, and it has to forward the data. So this is what we are going to consider here with respect to the operations. And the major issues, once if you are considering these operations, so server, where exactly server is located? It is there in beside our room. Now think that now only one server is there, and I have maybe 100 100 cameras are there surroundings of the server. Now all the servers able to, all the sensor nodes are maybe all sensor nodes able to send the data to the server at the same time, whether your server is able to manage that entire data at the same time. For example, now I am taking the class, maybe another faculty is coming and he is also started speaking. So which one you will take? Either you will take only one person, or you will not take any one person. Okay, so or maybe you cannot take both the persons. That is too difficult, right? So similarly, if multiple persons are planning to send same time data to you, you cannot take the data. Any one only you will take, another one you will drop. Okay, data loss will be there with respect to that. So that we need to think there. Right. So once many to one. So one person is receiving the data and many persons are communicating. So there is a problem automatically. So that's what maybe it will consume, it will create the data loss because of the congestion. Right. Because of the congestion, it is going to create the data loss. And maybe automatically it is going to be, if number of nodes are increased, then what will happen here? It is going to be redundant data generation. For example, we have the sensors here. The server which is going to collect each 15 minutes the data in particular each and every room. So now in this room, we kept one sensor here, another sensor there. Currently classes is happening and we are switching on the ACs. Maybe temperature will be in between 18 to 25 or 26. will consider. So it will be there from morning 9 to evening 5 o'clock. That is fixed time. Now, is it required these two sensors sensing the data and sending the same data? Consider here this entire room temperature will be 24, always from morning 9 to evening 4. In this time, both sensors should work. Not required, right? Both sensors are generating same data. What is the requirement? So one sensor can sleep for some, one sensor no need to work, and only one sensor, if it is working, I can send those data. If two sensors working, what is the problem? These two sensors has to find it out the path to the server, and both has to send the data. Now both are sending the data. Server should be ready to take the data. Now it has to create some time for taking this both the data. After taking both the data are same, so then server time is wasted, right? So that's what also we need to consider. That's what maybe here, if I am generating the redundant data, what will be the case if large number of nodes are there? And this will create the bandwidth wastage. You are wasting the time of server to receive, right? And maybe the scalability, the another issue. So how many sensor nodes I can keep so that my server will be active according to the sensor nodes. So this also, it is another concern with respect to this thing. And in addition to that, these are always the problem. So data transmission, I said already, it is going to consume much more energy than just generating the data. Maybe I am keeping sensor here that it will consume some energy for identifying what will be the room temperature. But same time, whatever it is identified, it has to forward to the base station. Why it has to forward to the base station? The problems is, I don't know whether this sensor node is having full battery, because maybe if I am deploying the sensor node in a forest, so it may be there for 1 week or maybe 2 weeks. After that, it may die. And after that, we may not find it out where exactly we kept the sensor in forest. So if you are able to move and find it out where I kept the sensor, then no need to monitor entire forest, because you are able to go and monitor. Right? Instead of that, we are keeping the sensor so that the sensors will monitor. But the problem with respect to the sensors which are deployed in the forest is the connectivity with respect to the power. So it is going to work with the battery power. So automatically, once if I started transmitting, it is going to consume much energy. That leads to the limited energy resources because of the placements. Maybe now if I am considering the temperature which I kept in this room, it may be fully powered. 24/7 it will be powered. No issue with respect to the sensor. Considering here, maybe the sensor which I kept, which is working under the battery. So automatically that battery will be drained after some days. So you need to replace that battery. So how we are going to put? Right? What way, if you are finding out what is the best process to replace that batteries, that we need to find it out. So that is the another research problem with respect to the wireless sensor networks. So these are the different kind of sensor nodes which are currently using your smartwatches, or maybe all your cooking things, maybe your wheelchair, mouse, camcorder, washing machines, self-driving car, smart remote, computer, everything which is connected with your sensors. Okay, those sensors are able to collect the data and it is going to forward to the base station. Fine. So now I said the application is I need to monitor the vehicles which are, my own vehicle. I am not going to monitor all the vehicles. I want to monitor my own vehicle, whether it is properly used or maybe any other persons who are not having licenses they are using, or maybe the unknown person, he is not at all a relative to me, but somehow he took my vehicle. So I need to find it out who took my vehicle and where exactly the vehicle location, that I need to find it out. So now for that, we designed one kind of protocol here. So this protocol is a wireless sensor network based protocol. So what we did here with respect to this one is, so now I hope you know how river will be forming, how river will join into the sea. So one place water will be generated, maybe the source of water will be anything, either it may be rain or it may be some other natural resources, something water is generating. So once water is generated, how it is going to join to the sea? So based on the altitude position of the land, it is going to move from higher altitude to the lower altitude. From that, it is going to finally move to the sea. So that's what here river formation dynamics. So that based on this river formation dynamics, we are going to connect wireless sensor networks. What kind of concept we are using here? The water drops, whatever we are generating here, that is going to be in rain. or maybe river generation. Same way, the sensor nodes which will generate the data. How river is generating the drops, water drops, like that your sensor nodes will generate the data. So now what you need to do, you need to send to the base station. Same way, this water finally where it will reach. So it will reach to the sea. So this is the case. Now C is equal to the base station, and how it is going to reach with the help of river. Same thing I am considering here it as a path. So how this river is forming with respect to the altitude position of the land. From higher altitude position to lower altitude position, water will move, right? So same way here we are taking here hop count and remaining energy of the nodes. What will be the distance between to me and maybe to the server? Based on that, I am going to find it out to which place I am sending the data. It will transfer my data to the server safely. So that's what I need to find it out, just like based on these altitude positions. Okay, so that is the concept here we are going to consider. Yeah, so this is the concept here. Maybe now I'm going to find it out. So these are the circles what we are considering here. It is going to be the communication radius. Communication radius of each sensor node. Now this is going to be the base station. Now it is having the communication radius here. Maybe we considered here 20 meters. Maybe the each your Wi-Fi or it may be any device which is having 20 to 30 meters distance. Or maybe Zigbee if we are taking in without obstacles, it will communicate up to 1 kilometer. Once any kind of obstacles are there, it will come less than 500 meters. So that's the reason we considered here maybe 20 meters distance. So now the different kind of sensor nodes are deployed and server is located here. Maybe consider my server is there and maybe within 20 meters circulation, maybe this entire building. I can directly transfer the data to the server without finding out any kind of intermediate node. So consider maybe the sensor node or maybe camera which is outside the this particular block. Then it has to find it out who is there maybe nearby to the server. So I can send the data to that particular node that it will take to the base station. So that is the kind of communication we are taking here. So now these are the regions how I divided with respect to the transmission range, and maybe this node want to transmit the data. Consider. So this node, it is going to find it out according to the formula with respect to the remaining energy and maybe the hop count. What is the hop count here? So this is 0th hop count distance. Whatever it is there within 20 meters range with respect to the server, that is 0 distance. So the hop count is 0 here. And maybe now if I am considering, so I need to have one hop count here. From here to here I need to send. From there to server I need to send. So that is going to be maybe we'll consider this one is one hop count. Then it is going to be 2 hop, right? So that's what we are going to consider here with respect to this application. Now this node will try to identify who are the neighbors to me. Who are the neighbors to me? Why I need to identify neighbors? Because I am not having directly communicated with the server. I cannot communicate directly to the server. So I need to find the path. For example, consider you need to move to Chennai. What is the best way to move? You don't know the path how to move to Chennai. What you will do? First, they will say, first you go to Cochin. From Cochin, you find it out maybe towards Coimbatore. From Coimbatore, you take the bus to Chennai. So this is the path they will give. So now that is the same case we are also taking here. Now this guy, he is located in IIIT Kottayam. He need to move to Chennai. Now he has to find it out. There is no direct bus. So now you need to find it out. What is the hops? What is the best hop? Next hop. First you need to go out from here. From there you need to take bus to Pala. So that is one hop. From Pala to Kottayam you need to take, or maybe from Pala to Cochin you need to take. From there you need to take another bus. So that is the path you are taking here. So now why you are selecting only these nodes? Because I have the connectivity towards Pala only. There is no other connectivity. I need to reach Pala if I want to go out. So now only possibility. So that's what here. So what is the connectivity here? So these are the nodes which are having connectivity with this node. So I am communicating with them. So they will take my data to the next level. So it may reach to the base station next. So that's what we are going to do here with respect to this particular application. I hope you understood with respect to what exactly happening here. Right. So now what happened? Some network connectivity issue. I wired connection, only one wire, right? Shall I connect this one? Yeah. Sorry for the disconnection with respect to the internet. Fine. So that's what we are identifying here. We are finding the path and we are reaching to the base station without any kind of problems. That's what the path we are selecting here, maybe multi-hop routing protocol. So with the help of that one. So now based on this, we are going to see one or two applications with respect to this one. Fine. So the application model, if I am taking here, so I need to monitor the vehicle or maybe your home or maybe your agriculture land. Everything you are going to connect the sensors and you are going to sit in your home and you are going to switch on the motor. Or maybe consider your terrace, you have one water tank. You need to fill that water tank. So when it is going to finish, exactly whenever I am planning to go to the college, by that time my water will be finished daily. So I should not get similar kind of activity. So I should not wait until it is filling up. Then I need to take bath and I need to come out. Right. This is the general scenario we used to get. Maybe water will be over. So while I am getting into the bathroom. So now I need to take into the consideration. So what kind of thing we are going to take with respect to that? So maybe you can take any kind of application. So automatically once it is reaching to the lowest level of the water in your water tank, automatically it has to send the signal to you as well as it has to send your motor should switch on. Once it is motor switch on, it will fill the water. After it reaching to the highest level, automatically it has to send the signal to the motor. You can switch off the motor. And it will send also signal to the corresponding owner. I am switching off the motor because already water filled with the water tank. Right. So automatically this if it is creating, so there won't be any issue with respect to that. You don't need to bother and maybe you don't want to waste time for doing these kind of activities. So such kind of things, we are going to take one different kind of application here. So now why I did this particular work is, so while I am studying my PhD in NIT Trichy, so it is a 800 acres campus, right? So from my hostel to department, it is around 1.5 kilometers. So what I need to do daily, I need to go by walk or maybe I need to purchase. Not only me, the people who are staying in the hostels, around maybe 1 kilometer will be there from department to the hostel, all the departments. Now what we need to do, we need to take somehow purchase cycles because there is no bikes allowed and maybe once again license issues and other issues will come because of the BTech age. Right. So we need to, that is kind of environment friendly environment friendly campus is that. So they are not allowing bikes. So now we need to purchase cycles. So now every year there will be around 2,500 to 3,000 students will join. So how many cycles we need to purchase? 2,000 cycles minimum we need to purchase. So how many keys should be there for each cycle? Only one key. And all 2,000 different keys should be there for each cycle, right? The problem is there won't be any different key. Somehow at least one or two cycles will match with the same key. Now what is problem here? I purchased a cycle, 10 days I used, 11th day my cycle is not there. In where I kept my cycle in front of my department, it was not there. So I was searching. So cycle was not there, what I need to do? So now I need to go by walk. So 2 days I walked, third day I went to department, third day my cycle is there. So what happened here? The key, whatever I am having, same key will be applicable to the other cycle. So he opened by mistakenly, he is the BTech student, he used to come for lab to the department. So he came to the lab Monday morning, he kept his cycle there. Then after that what he did, So while he is going back, unknowingly, while he is talking with his friends, he took my cycle and went. His cycle is there only, but it is in different location where I used to keep. I am checking, my cycle is not there. So after 2 days, I identified my cycle was there. So then I took my cycle. Then after that, no one took. So that is fine. The case is here. This is one kind of scenario. There may be a chance some other people, they may use your cycle without your intervention. Another thing is, now for example, I completed my PhD. I left my cycle there itself and I came out. So where I will keep either in hostel or either in department. So how many cycles they will keep like this every year? Maybe per department, 100 students per year they will leave. Maybe 200 students per year they will leave. So 200 cycles if they are keeping in front of department, after 4 years, it will be huge things will be there. So who will clean? So now for this one, so that neighboring institute people will come for daily wages work. So they will check how many days onwards these cycles are here. So what they will do, they will shift the cycles from one location to the other location. After 1 week, it will go out. Then they will remodel it and they will resell to the college people itself. So that is the kind of business they used to do. Anyway, that is not necessary for us. But only here is security concern, whether my cycle will be with me or not. So then now we started thinking about that particular work, and maybe we started solving that particular thing with the help of IoT. So for that, what we made is, so here we kept it as a bike, but generally we kept for cycles also this one. So here there is a sensors. Yeah. So I said already, previously I shown one diagram, Zigbee diagram, right? One device. So that Zigbee device is going to give you communication between different parts. So that Zigbee you can use in 3 different places, maybe 3 different variants. One is base station. Another variant is router. Another variant is end device. So where this base station can receive the data and can forward the data. And it will having the another application here, maybe gateway application or maybe database. It is connected with the your base station. So it will store the data also. And same way, you have the router. So what router will do, whenever any device or maybe any cycle which is coming our communication, then it will forward the data. I found one cycle in this location. So I am forwarding this data to you, to the base station it is sending. Right. So now what this end device, whenever I am moving, any router if I am finding, so this end device, it's keep on searching any persons or surroundings to me. So it will keep on searching and it will find it out. So once if it is finding, then it will send the details. Okay, currently my location is here. Then it will send to the router. Router will take that data to the server. Okay, or base station. So that is the kind of communication we are having here. So now in my lab, I set up a base station or a server which is connected with the Raspberry Pi. So this is the end device where I am able to collect the data. I am able to store the data with the help of XML format. So now these routers we kept in 2 different departments, maybe neighboring departments. Maybe the structure here with respect to colleges, maybe this is the 1/4 or 1/3 of entire institute, not 1/3, 1/4 or 1/5. So where I kept maybe around 8 buildings. So there my surrounding, maybe this is a Department of Computer Science and Engineering, and maybe Instrumentation of Control Engineering and IIIT, IIM Tiruchi at that time it is working there. So now I kept here one sensor, another sensor here I kept. So these 2 are the routers. Okay, these are the routers and this is the base station I kept here. So now this base station will receive or communicate with these routers as well as to the end device also. It will receive the data and it will store it inside that database. And same way, these end devices, if I am taking, these are connected with the Zigbee router and the vehicle number or maybe the vehicle name, I can say. That vehicle name we kept here, and it is whenever it is moving here, there is a communication between the end device inside this one, Zigbee, and the device inside this router. These 2 will communicate and it will send the details. Okay, I am so and so. Currently, I am, so this is what, maybe I am in Department of CSE. What is the vehicle number? What is the time? So while I am moving. So same thing it will happen here. At the same time, sometimes this vehicle may communicate with these 2 because the region, maybe 20 meters region I said. So within 20 meters, whoever is there, it will communicate. So like that, this particular device is able to communicate with these two departments. Right. So now this what we did with respect to that, so that we are able to collect the data. So this is about only data collection. So now what kind of things you can do here? So you need to find it out. Now, for example, I am sitting in my cabin or maybe my room. So now I need to get alerted whenever my cycle is moving out. Maybe any student is taking and is moving out, I should get alert. Right. Then only I can take the action. So for that, what you need to do? So whenever it is moving, automatically I will get alerted. So currently you are in front of maybe ICE department, instrumentation department. So then automatically I will get alert. Okay, currently I am not in instrumentation, I am in department of CSE only. So I need to find it out who took my cycle, whether I gave it to anyone or maybe someone took intentionally. So that I will get some kind of alert message and I will be alerted and I am going to find it out where exactly my cycle is there. Right. So this one we extended to the four-wheelers also, where there will be a required more number of other sensors. Maybe consider here, I need to find it out where the vehicle is. For that, you can have only the communication with respect to this one is. This is Arduino board. This is Arduino board, and which is only Zigbee with in addition to the battery power. Okay, only those things we connected initially. Now what we made here with respect to vehicles, we need to increase additional kind of sensors. Maybe here you see ultrasonic sensor we kept here. There are 6 sensors we used for entire vehicle. So that whenever any object is coming surroundings of that vehicle, automatically it will inform to me, it will alert the driver, some object is there at some particular position. So you be alerted whether it is backside or maybe side while you are crossing the road. So that kind of alert message I may get as a driver from these sensors. And maybe you just check here, maybe RFID. This is generally now currently all vehicles is having. Maybe four-wheeler if you are taking, either it may have some Bluetooth or maybe RFID tag with your key. So it will be open. So this RFID is used for that one. And maybe CO2 sensor, how much pollution parameters. Now currently if pollution, how much it is generating, you need to generate some pollution bill every 6 months or every 1 year. So that you can generate by your own here with respect to these things. And maybe CO sensor now currently it is not happening. Earlier days, car blasting is more oftenly used to happen. So because of maybe some problems inside the car, they will keep AC and full, and while they are traveling itself, there will be a blast happen. When I was in my BTech, I used to get these kind of messages because my institute is beside highway road, NH5. NH45 something is there now currently. That is from Chennai to Kolkata. So in that highway, rarely I used to get, more oftenly I used to get some kind of blast happen on the main road, car blasted and maybe 4 or 5 people died. So that is because of maybe some CO, different kind of gases problem also it will generate and it will fire with respect to that one because of the heat and other stuff. So then we started checking CO sensor also, what will be the case inside the vehicle. And while your driver is able to drive properly or not, he is getting any kind of drowsiness or maybe sleeping, that I need to check while he is driving, right? So for that I am using here maybe with respect to the alcohol detection sensor as well as camera, whether he is alcoholic, he is taking more alcohol and he is going. So those things I need to check. So for that reason we used these sensors. And it is able to now, we kept camera here at the steering place and we are able to capture the photo of this person. And it is going to find it out whether he is going to sleep or whether he is normally is riding. And before that, this is going to checking who is driving the vehicle first. Whether the driver is having valid, first of all, I'm going to send the data to the police or maybe local police or maybe RTO office so that they will have the data, they will match whether this particular guy is having license or not, valid license or not. And second thing is the details who is taking, it will be transferred to the RTO and it is going to collect whether he is having valid license or not. If it is not matched, it is going to alert the owner. This particular person is riding the vehicle. Your vehicle is riding, whether you know him or not. If you know, he is going to alert him regarding this one because the person who is riding, he is not having the license, but no one is there beside him. So we need to alert him as a owner to the owner itself. So you should not allow him as alone. You need to, some person should accompany while he is learning the stage, right? So that's what you can give. Another thing may be whether if I am sending the photo to the owner, he will recognize whether the person who is using the vehicle, he is authorized person to take my vehicle or not, right? So those things we are able to find it out with respect to the sensor. So for that, we require now who is riding the vehicle. So for that, we require some kind of deep learning algorithm. So that's what we are checking here. So now this deep learning algorithm, what it is going to find it out, while I am riding the vehicle, it is going to find it out the face. So MTCNN is the algorithm where it is going to take the face and it is going to try to map with the database, right? It is going to capture the face, and this face, from this I am considering the face embedding and I am finding out with the help of face recognition algorithm. What this face recognition algorithm will do, it is going to map with the database whether these people already having the license or not. If it is valid license, then no issue. If it is not having valid license, then RTO should send some kind of message to the owner. Your vehicle is taken by someone who is not having the valid license. Okay, so automatically he is not having the valid license. He is not with respect to the owner database also. Then automatically owner also will get some kind of alert message. Someone who is not in your database is taking your vehicle and riding. So please take care about that one. So that's what it is going to check here. So your face detection is going to detect the face, and this is given to the face recognition module where your database, you have all the images of the your own relatives or maybe persons who are riding your vehicle, their photos will be there. It is going to map and it is going to check whether he is having license or not, or maybe he is a valid person or not. Then after that, this face extraction, it is going to check the eye aspect ratio, so that whether he is riding properly or maybe he is having he is feeling with some dizziness or not. Those things we are going to check with the help of the eye aspect ratio, and it is going to give some kind of alert whether he is closing eyes or maybe something if it is happening with respect to that. So that's what the one application here. Even we try to test with the different kind of light scenarios, whether more light is there, what will be the scenario, whether it is able to detect, or maybe driver with mask and without mask, and with light and maybe drowsiness situation. If I am closing the eyes, so it will be giving some kind of alert, some kind of buzzer will start giving the some alarm, so that I will be get alerted and I will may take some rest and I will start riding the vehicle. So that's the concept here with respect to the vehicular monitoring. So if possible, we'll see the how it is going to work. And maybe another application here is, so similar kind of application where we started this one in the Department of Computer Science Research Lab. So actually, generally in a research scholars lab, it will be 24/7 open lab, and key will be there only one, and maybe around 20 to 25 people will be sitting in that lab. So now what will be the problem here? So some people will be interested morning 4, they will come to lab and they will study and they will go. Other people will be interested midnight, so they will come and they will do until 2 o'clock or 3 o'clock and they will go. So no one will sitting from morning 4 to evening 12 o'clock. So some people, they'll keep on moving, and most of the things in the research scholars point of view, they will not only they will go to the room for sleeping, no other things, only for sleeping, getting ready and coming back. Remaining all their luggage and all, everything will be there beside their cabin itself. Now in this scenario, so mostly all the students, they are having textbooks with them itself. So now we need to check what will be the privacy with respect to their own material, and maybe their own the lab related things. Any persons are using their own system, we need to monitor. And what will be the security with respect to the lab. So because that lab will be open 24/7, opposite to that there will be one MTech lab. So that is also open, but the case is here, the way the thinking of the MTech students will be different from the PhD students. And the timing will be different. And sometimes they want some textbooks, they will come directly to PhD lab and they may take and they may not return. So that is the another problem we used to get there. So for that reason, we started thinking about that one, and we started implementing this kind of scenario here. So what we made, this is the lab what we are having there. Okay, this is the lab. Maybe consider this is the lab. People are coming and they will go. So there won't be any key. Indirectly, there won't be any key because it is open 24/7. Even it is having key, mostly we won't lock. Or if you are locking, we need to keep in one particular location. There they will go and take. Now, for example, I am leaving by 7 o'clock. By 7, no one is there. By the time if I am leaving and I am depositing key there, someone who is coming, they need to open and they need to come inside. So what will happen there? So some people, they will go for 2 minutes walk outside, they will walk and they will come back. By the time if I want to leave, no one is there. When I saw no one is there, I will lock and I will keep deposit there in key ground floor, then I will leave. It is in first floor, key deposit position will be in ground floor. So I need to go there and I need to deposit and I need to go out. Now the person who went for walk for 2 minutes, he came back. It was closed. So now what you need to do, you need to go away because he came from down itself, but you need to go down and you need to take that key and you need to open once again. This is one case, or maybe sometimes another case is maybe the security with respect to your own things in the lab. So those two concerns. Now, this is the setup we made. So there will be 3 sensors we kept here. So this is the entrance you may consider here. So in this entrance, here we kept one sensor, this particular location. And maybe exactly top of the door, we kept another sensor. And maybe outside another sensor. So those sensors are PIR sensors, passive infrared ray sensors. It is going to find it out, the movement of the object. Okay, any movement is there, it is going to find it out and it is going to give it to you. Okay, some object is moving in front of me. That's what maybe object detection. We are going to use that PIR sensors. Now, so what it will do, whenever I am opening the door, or maybe if I am roaming outside the door, it is going to instruct to me, or maybe now another problem here is I am keeping the camera. I said already, what is the problem with respect to the cameras? It has to monitor and it has to generate, and storage problem will be the very big issue. Right? So I can't store maybe more than 2 days or 3 days. That's what the, even maybe if you are going and you are asking your college, how many days we are storing means 2 days only they will say, not more than that. So automatically it will be removed and replaced with current day. That's what they use today. So now that is the problem. So now what I am doing, whenever person is opening and coming inside, that time only my camera should switch on. Otherwise it is not required, right? No need to monitor 24/7. Right? So the camera which is coming inside, so that I can monitor who is the persons coming inside at what time. So those things I can monitor. Who is the persons who are leaving at what time? What are the things they are having and they are going? So that we used to monitor here. So for that, this PIR sensor is going to detect the object motion. So how many people are going out? How many people are coming in? So once it is detected, maybe outside I am moving. So inside no one is there. So that time I am planning to open the door. Whenever I am opening the door, my second sensor will be activated and it will wake up the camera. So camera, you please wake up. Someone is opened the door. So when it said, then automatically it will start capturing the photos. So it will take maybe continuously some 5-6 photos and it will store into the database and it with time. Okay, with the time. So that maybe I may monitor and I may get some kind of alert with respect to that message. Okay, and that's what the entire thing here we are having here. So this is the setup. This what maybe the outside the door, and this is top of the door exactly, and this is the inside the room. This is the sensor. Okay, these 3 sensors will be there, and this is the radio transmitter Zigbee device. That Zigbee device is connected to this device, which is located exactly entrance of the maybe here I am keeping. Okay, this system I am keeping so that it will take and it will capture the photos. So that's what the setup we made here with respect to that PIR sensors. Whenever PIR sensor is able to detect either maybe person is moving inside or outside, so that particular sensor will be activated and it is going to give signal to the camera, you be switch on because someone is moving in front of me. So once if I am opening the door, automatically camera will be switch on and it will start capturing the photos. Now what is the advantage with respect to this method is, you no need to store 500 MB of data per day. Whenever door is opening, I can capture the photos, I can close the door. Right? Whenever I am going out, I can capture. Otherwise, what will be the problem? For example, I lost my book, I need to check. If continuous video is there from morning to evening, I need to sit minimum 1 hour to find it out who are the people went with what. Everything I need to monitor and I need to keep. Right? If I am having the photos whenever they are coming and they are going, so it will be easy for me to find it out easily. Instead of sitting for 1 hour, I can do it within half an hour itself. Right? Or maybe I may make it automatic system so that my deep learning will algorithm will detect. So maybe if I am giving books, the people who are going with books, you need to identify today's date. Then it will give you me all the details. Okay. Or maybe at that same time, I need to check the people who are coming with the books inside and who are going with the books. So both I will mismatch. I mean, I will map with those books and I will get clarify whether they took whatever books they brought inside, they took with that same books or maybe any other books they replaced. Right? So those are the some kind of applications we can do with this particular application. So this what may be the different kind of images they considered while I am taking the door, while I am moving outside and other stuff. So then now we need to find it out whether the person who is roaming outside or maybe who is entering inside, I need to detect automatically. Maybe someone who is going to be responsible for that lab. So one person will be there for responsibility of that lab. So he has to find it out what will be the abnormal case. Maybe in my lab also printer also will be there. Some MTech students, they used to come and they used to take printouts and they used to go. So we need to monitor that printer. Finally, while we are calculating the amount, we need to keep, I mean, our PhD scholars itself, we used to keep for refilling that one. So whenever we are calculating, there will be a mismatch with respect to number of pages we took and how many pages it gave it to us. So there will be 100 to 200 pages difference used to get. So that also we start evaluating that one. Now, who are the people are coming inside? I need to find it out. So now, who are the authorized people? Faculty of NIT Trichy, Department of CSE, and maybe the students, PhD scholars inside the department. Other people and all, they are not authorized person. So we need to find it out. So for that, we maintained some kind of database here. We are taking the picture, we are sending to the face recognition model. So it is able to detect who are the people who came, at what time they came, whether they are known persons or unknown persons. Right? So that's what the another thing maybe here with respect to this one. Actually, this particular work we did with respect to triviality quotime status. So up to previous thing. So up to collecting the data we did in NIT Trichy. After that, maybe here we did with one BTech student same application. So there we are able to find it out. Authorized persons and maybe unauthorized users who are coming inside the. So it is going to give it to us the name who are the people are coming inside. Right, including photo that also will send to us, even WhatsApp also here. So WhatsApp also it will send who are the people are coming inside at what time. So whether they are authorized persons or maybe unauthorized persons, that maybe you see here. Even if I am giving with the photo, I am showing with that, it is able to identify the person photo. So what is the advantage this MTCNN? So here anyway, while I am entering, so very less people only will enter, maybe hardly less than 5 people per at a time. Right? So that time I can capture easily photos. I don't want to like maybe if you are taking YOLO model, so it will be processing capabilities higher, even maybe with less power capabilities. But here MTCNN will require maybe less number of frames it will take. Per time it will process only 4 frames maximum. And it is able to detect properly. Why we consider this one is because the faces what we are going to get is very less. If huge number of faces are coming, then we need to increase the processing capability. There maybe you may use YOLO models and other models to check each and every face. So here anyway we are getting very less number of faces. So that's the reason we used MTCNN here. Right? Yeah. So maybe if you are willing, maybe I will show the how it is going to give the execution thing. So is it fine, sir? maybe I can take here face recognition. It will take for 2 minutes for setting the camera and other things. Sir, is it the entire screen I shared? Yeah. It will take 2 minutes to load everything. So automatically it is going to check whether I am authorized person inside the lab, or it may be even same application we can think with respect to your home perspectives. So any now in my home, only my grandmother is there. So she is unable to move from the bed. So now all people are going for work. So I need to monitor my house. So who are the people are coming, who are the people are not coming, all these things I need to monitor. So in that case, I need to keep some kind of camera entrance of the house so that it will start monitoring the people. And maybe yeah, we'll check this one application. So it will start capturing the photos and it is going to recognize. Okay, so it will give you what kind of, I mean, what is the person who identified. So with respect to the database, it is going to check. The camera should switch on. It is taking somewhere. So it is giving to me now unknown person, because maybe some other maybe that time I took with respect to the hair, full hair. That is the thing I gave. So I need to check with respect to that thing also. So maybe yeah, now it is giving to me correctly with respect to the other things and all. Eye aspect ratio also it is going to calculate here. And once if I am closing the eyes, it is going to give some kind of information with respect to that closing eyes also. Maybe this is only for if I am closing for 5 minutes. So the drowsiness is there, you see. Drowsy one it is giving, right? The drowsy one, if it is reaching to 5 seconds continuously, if I am closing my eyes, so it is going to give some kind of some alarm to us. I think it became. Yeah, some sound it is coming. Maybe I kept in mute, right? So that's the reason it is not given. Okay, otherwise it is going to give some kind of alarm to you with respect to that drowsiness. Yeah. So this is what the application what we made here. We used MTCNN. So that MTCNN is able to recognize. Yeah, it is able to recognize the image. After, sorry, it is able to detect the image. Then it is going to forward to the face recognition model. So that face recognition model, it is going to take and it is going to identify. So who is the person according to your database is available or not. So same thing you can think with respect to vehicle driver also. It will take, it will recognize. If it is unknown person, it will send the WhatsApp message to the author. I mean, the authorized person. That's what it is going to do there with respect to this particular application. So you can take, there are different kind of applications. So you can think now maybe 2-3 applications we discussed. So maybe your general daily activities itself you can make with the IoT sensors and you can implement. And maybe once you started implementing, then you will understand what will be the, I mean, how much easy it is. And same way here, once again, we need to discuss maybe other parameters. One may be the people who are saying about the my main topic is privacy and security, right? So what is the privacy issue here? I should not take all the photos who are visiting my lab. So that is also issue, right? So someone who is coming, so if he is keeping case, why he is taking my photo? Irrespective, without taking his thing, I am taking the photo. So how we are going to solve this issue? So that is also one privacy issue with respect to IoT. Maybe we are considering here what kind of privacy with respect to your own lab, no one should use. Okay, that is the privacy we are taking. So if someone is using, I am taking your photo and I am making whether it is happened due to you or not. Right? Maybe another case, if you are taking, why I am taking other person photos, what purpose I am taking. So that is another privacy issue and security issue you need to handle. So these are the sensors which are not having any control. Even now I kept some 100 sensors. Now outside another guy, he kept one sensor which is able to give the information to us itself. Or it may be that sensor is able to collect the information for them itself. Maybe the entrance, I kept one camera. So beside that one person, outside person, he kept one sensor there. He is able to collect the data because he know what way we are collecting the data. So automatically he designed such kind of router there and he is collecting the data. Now whenever I am checking my router or maybe my server, I am not getting the details of the entrance. Why it is happening? Because it is going to some other sensor, and from that it is going to some other server node. Because even it is not our concern, or maybe it is not within our network, even though it is going out. Because the connectivities and other things, it is not with respect to the standards. So your own things you can take and you can set all these things and you can use that particular protocol. That particular prototype. So the problem here is it is not standardized thing. So anyone can use in whatever way they want. So that will be the one privacy issue with respect to this one. So we need to be always alert with respect to those kind of things. What are the devices are communicating, and maybe how it is going to communicate. So you need to find it out how you are going to be able to give that device communication. For example, if it is identifying the server node, sensor node, which is not within our region, they identified what kind of numbers we need to give as a router. So that router number they gave, but still the particular sensor which is forwarding the data to that outside server, it has to identify to whom I am sending. How I am going to identify it is abnormal person. So that is very big issue with respect to IoT things. So you need to identify and you need to set some kind of internal security itself. So you should not give any kind of data outside while you are designing your prototype. So once you started giving, then automatically other people, they will start installing other kind of devices which is going to collect the data, and that data will be spreaded over the world simply. So that you need to consider with respect to the privacy issue also. So there are so many application domains. You have agriculture nowadays. It is just like a kind of buzzword with respect to IoT. So you have drones and other stuff, everything drones has to do, and even maybe labor cost is increased because of other problems. So now earlier, while I am studying my BTech, that time in my village, labor cost is 100 rupees per day. Now currently, even if you are giving 500 rupees, labor is not coming because of the globalization and other things. They are not at all coming. So what we need to do, we need to have some kind of our own mechanisms to introduce and maybe solve such kind of issues. So maybe your agriculture, e-health nowadays, this is now if you are going to the hospital, whether you have any particular disease or not, you will get connected with so many devices. And the doctor will not check anything. So those devices will be connected to you and it will monitor and it will be given to the data to the doctor. If you are going directly to the doctor, they are not giving any report to you also. You will directly go to the doctor. Doctor will see all the reports through online itself and he will suggest to you these kind of problems you are having. So all these things, how it is happening because of these IoT sensors. There will be so many, from temperature onwards, for everything they are going to take with respect to the sensor itself. So that's what maybe the healthcare you are having and maybe the smart attendance system. So this currently it is not fully developed. I think maybe now they are planning to take, maybe with respect to your, maybe where we used to get the attendance in NIT Tiruchi, we used to thumb or maybe we used to sign daily in the register. So that it became thumb. So later they may take with respect to the thumb also they may forger, right? So that also they may change with respect to the photo. So or maybe while I am taking the attendance, currently in IIIT Kottayam, we have the student strength of per class is 130, around 130. So consider how much time we will take to take the attendance. It will be 15 minutes minimum we need to take. So that 15 minutes we are going to waste every day. So instead of that, if we are keeping any kind of attendance system so that student itself is able to give, or maybe the camera if I am keeping that it is able to monitor or maybe detect and it is going to give the attendance. So I am going to save 15 minutes. I am going to use that 15 minutes for some other purpose. So those are the things we can take into the consideration. With respect to this, already I said in library, if you are going, you can come with that RFID reader in your book, and maybe RFID reader will be there that it is going to give the signal to the corresponding people whether you are taking this one, I think RFID reader here. Right, this is the reader. Once you are crossing RFID reader system, so it is able to detect that RFID, and if it is allowed, then it will be allowed, otherwise it is too difficult. And this is another communication what we discussed according to our application. So now it has to find it out when car is starting, it has to find it out the best path where I can take very less time to reach, and there won't be any kind of traffic details and everything I need to collect. Right, so that's what maybe that smart city concept we are going to do. And maybe these are the some applications. So now if you want to send any kind of WhatsApp messages, that's what I shown, right, with respect to the images. So once if I am selecting, so you can see this particular YouTube link that I will share with your coordinator. So he will share this PPT to you. Maybe if you want, you can check that YouTube link there, how we are going to send a WhatsApp image to the particular person, or maybe you want to wish your friend he is having a birthday. You no need to awake until 12 o'clock daily night and you need to wish him. So instead of that, you are setting some kind of algorithm here, automatically it will give, or maybe it will send some by default message to your friend, so that your friend will be happy and tomorrow you will get big party. Right, so that's what maybe you can do with this material with respect to these things. And maybe these are the reference papers what we did here. So almost the papers which we did, it is presented there. So that if you want, you can refer, or it maybe you may communicate with this particular mail ID, or maybe second number is my WhatsApp number. If you're having some kind of issues with respect to these applications, then you may communicate with my second number WhatsApp number. I will share the material with him, or if you are having any doubts, maybe we may take that one.
Any queries from offline? Okay. So any queries from online participant? If you are having, you can either unmute yourself or you can text it in the chat box.
Fine. I think no questions.
No queries. Thank you, sir. Thank you so much for your valuable inputs.
Thank you. Thank you for giving the opportunity.
Okay. Yeah, we are coming to the end of day 4 sessions. We will meet you in tomorrow, the final day of this 1 week FTP program. Yes. Yeah. Thank you.